Right, I'll shut up then. I'll put myself on mute.
And it says we're live. Yeah, apparently so. Hey, it's showtime. And a good afternoon, Bebby and Alan Evans in here. How you guys?
I'm fine.
Good. And we got Bebby with us. We're going to talk about, well, we're not going to. Bebby is going to talk about Aristotle. We're going to have some fun this afternoon. You with us, Bebby?
I'm ready. So shall I kick off?
Yeah,
Maybe I've got the right date. It is the 11th today, isn't it?
Today is the 11th of July.
Excellent. So off we go.
It is 2023. All of that is good.
That's all good.
Yeah. We don't have a lot of people watching yet. We got 18. Or at least that's what my YouTube is saying right now. That will probably pick up as we go along. And right now I've got the voice just restricted to the three of us in here, but a little later on we'll all move into probably the Discord general chat and open this up and let anybody that wants to come in hop in and ask questions or do whatever. But I think with that, maybe if you want to go ahead, get going. We're ready.
What I'm seeing on the YouTube is not the same. Is there a slight delay there, Blue?
Yeah, you're going to see about a 30-second delay on YouTube.
Okay, so I'll out of that. Okay, let me start.
Yeah, we'll be seeing it in here as you do it. But the folks out in YouTube are hearing us delayed by about 30 seconds and seeing what you're putting up delayed by that
That's
much.
it. Yeah, I can see on the screen here. What I'm seeing is what I'm getting.
Yeah.
So, what am I here for? Objective. Set out and explain Aristotle's two-step argument for level not being horizontal, which so I put it to the guys on the level, and there was some sort of surprise and consternation about that because surely Aristotle would not have written about that. But I found this proof lying around in his voluminous writings, and I was astonished. Has this guy 2,300 years ago really thought about level not being horizontal? Well, it turns out he did, and he has a two-step argument for this. One is what I call the aporetic argument. It's all about gravity and why does the Earth not fall? Step two, an argument from equilibrium, which establishes that level is not horizontal. So I'm going to set those arguments out. I'm going to show why his argument is both valid and sound, and also provide sources for reasons I wouldn't normally do, but for reasons which I'll explain later. So a background on Greek science, which is really not much like modern science, in what they call the sublunary world, which is the world below the moon. So they thought the universe is composed of concentric spheres. There's everything under the moon is earthbound, where there's volition and movement. Everything above the moon is sort of motionless but eternal. In the sublunary world, there are just four elements: earth, air, fire, and water. Which is kind of not correct. I mean, these are not the elements as we know now, but this was more than 2,000 years ago.
Yeah, that was their perception, right?
That was their perception, yeah. I mean, they got an awful lot right, as we're going to see, but on most aspects of science, they got most of it wrong. So there are heavy and light objects. Heavy material like metal consists primarily of earth, with a smaller amount of the other three elements. So every bit of stuff you see, every material you see is a mixture of the four different elements. Lighter objects have less earth and more of the other light elements. And I'm saying this because there was really a lot of confusion on the level about the meaning of earth. I was saying that they were saying, "Oh, this earth is just dirt." You're saying the earth is made of dirt. Well, no. Earth is a technical term in Greek science. It means all the heavy stuff like copper, clay, vases, anything basically solid. And it bears a sort of relation, doesn't it, to the I did chemistry a long time ago, but there are three states of matter, aren't there? There's solid, liquid, and gas, and something plasma, is it?
Yeah,
Maybe
that's
you
the
guys know
fourth
better.
state. Yeah, right.
That's the fourth state. Okay, so they sort of got the idea from that, but they didn't. Apart from that, they didn't understand it too well. Now, the key thing here is gravity. For Aristotle in the ancient Greeks, gravity is absolutely not an attraction between objects. We're used to thinking, those of us versed in modern science are used to thinking of Newtonian mechanics, where gravity is explained as a force which is an attraction between different objects. So if we were to instantly annihilate the Earth, objects would not fall. They'd just be floating there. For Aristotle, gravity is the tendency for all bodies to move up or down towards the natural place. So everybody has a natural place. Heavy things sink to the bottom of all things that move downward. And light things, the lightest thing is that which rises to the surface of everything that moves upward. So air and fire are light, they go up. Water and earth go down. And because earth is sort of heavier, they wouldn't have said denser. They wouldn't have said denser. They'd have said
I was going to
heavier.
say, this is a frighteningly like ancient relative density disequilibrium, isn't it?
Sorry.
It's like relative density disequilibrium, sort of.
It is sort of, but they wouldn't think in terms of density. They just thought in terms of heaviness, if you like.
Yeah.
Okay, there are two parts to the proof. Proof part one. Aristotle starts with the observation that the Earth, although a massive and heavy object, does not fall through space. And then he shows from this that there must be a single point to which all heavy objects are drawn by nature. I'll show you the text here. The only reason is that I discussed with the guys on the level, and they were saying, well, this is Bebby's proof, this is your proof. And I said, bloody hell, no, it isn't. It's Aristotle's proof. And they kept denying this. And I thought, well, here's the bloody ancient Greek text, here is the argument. And it's at 294a 1120, which I'll explain in just one second. Becker numbering or Becker pagination is a standard formal way of citing Aristotle. So any text from Aristotle that you're referring to, you do 294, and that's the page number in Becker or the Berlin edition. A is the first column, so there's columns A and B, two-column work. This is column A, and then there are line numbers which you can see. If you can see my cursor, you've got line 15 there, so you can see I haven't been cheating. We've got line 11 starting there all the way to line 20. That is a Becker reference, and it's based on the page numbers used in the Prussian Academy of Sciences edition, written by, or rather edited by, Emanuel Becker in the 19th century. Aporia, right, literally means embarrassment or difficulty or perplexity or puzzle. In particular, and technically, it means a set of propositions, each with some claim to plausibility, which cannot all be true at the same time. And that's absolutely key. You have three or four or five, or any number of propositions you like. You'll then see, well, all of those cannot be true. At least one of them must be false. Most often phrased as a question in the works of Plato, Socrates. If you've read any Plato, Socrates asked lots and lots and lots of questions with the aim of getting the other person to dig a hole for themselves. And then Socrates will say, well, what about that? And then they realize they've made a mistake somewhere. And sometimes framed as a rhetorical question, i.e. a question you're asking for argumentative effect rather expecting an answer. That's aporia. And here is, right, there is the text. I'm going to read out. So on the level, guys, can't see I'm cheating. Okay, there's an English translation. I used as good a translation as I can find, but it's pretty literal translation of the Greek. So he says, one, a little bit of earth, let loose in midair, moves and will not stay still. I explained this to S.G. Montreal, if anyone knows him, the other day, and he said, no, things don't fall. Things do not fall. I said, well, yeah, S.E., they really do fall. If you take a bit of rock and hold it up in there and then drop it, then it will fall. So some things do fall until they hit something solid. 2, the whole Earth free in midair shows no movement at all. So here is this great weight of Earth, and it's at rest. And there's the question, sort of the question that's underlying in this aporia. Why is it? Why is it the Earth, which is a bloody great big heavy body, why doesn't it fall? Why is it in the air and at rest? He adds, really supporting this claim, from beneath one of these moving fragments of Earth before it falls, take away the Earth, and it will continue its downward movement with nothing to stop it. And the key point there is, in Newtonian mechanics, if you took away the entire Earth, leaving the sort of the objects on the surface, they would not fall, they'd just float in space. There would be a minimal attraction of one to another, a really small one, but they would not fall anymore. Whereas for Aristotle, there is a natural place for all bodies. Even if you take away the whole Earth, the objects on it would then just fall until with nothing to stop them. And he says the difficulty of why the Earth doesn't fall has naturally passed into a commonplace of philosophy. So in logical form, every piece of Earth, note the every, we've got a universal proposition here. Every piece of Earth, let loose in midair, moves and will not stay still. The Earth itself is a piece of Earth in midair. At 3, the Earth does not move but stays still. And if you look at that, logically, all of those propositions cannot be true. If every piece of Earth falls, and if the Earth is a piece of Earth in midair, then the Earth must fall, which contradicts 3. Or if you take 2 and 3, if those 2 are true, 1 must be false. If you take 1 and 3, if both those are true, 2 must be false. So that's a perfect aporia. One of the propositions must be false. All of them can't be true. So which one is false? Not everyone is puzzled by this. Mike Jones says, why do you feel the ground should fall, and the fact that it doesn't somehow needs to have an answer? Well, Aristotle says, well, the difficulty must have occurred to everyone. Aristotle's solution, proposition 1 is false. Let's look at proposition 1 again. Every piece of Earth let loose in midair moves and will not stay still. Now, he says it's true that any body endowed with weight of whatever size has an impulse towards the center. There is a single point in the universe to which any body will fall, but once it's reached the center, i.e. reached the center of the universe, it will not move any further. So proposition 1, the universal proposition, is true of any body that's not at the center and not being held up, but false of an object at the center. So it's not true of all bodies. Therefore, as a universal proposition, it is false. And he adds here at 297, page 297 of Becker, column B, line 2, starting line 2. Excuse me. Anybody endowed with weight of whatever size moves towards the center. Clearly, it will not stop when its edge touches the center. And he then says, slightly puzzling sentence, the greater quantity must prevail until the body's center occupies the center, i.e. occupies the center of the universe, for that is the goal of its impulse. That's the natural place that body wants to be. It makes no difference whether we apply this to a clod or common fragment of Earth or to the Earth as a whole. Therefore, the Earth in motion, whether in a mass or in fragments, necessarily continues to move until it occupies the center equally every way, the less being forced to equalize itself by the greater owing to the forward drive of the impulse. That's a little bit confusing, but what he means is this. Suppose there's nothing else in the universe apart from a circular piece of Earth, a clod. When that touches the center, it will still keep going because it's still heavy in that direction. It'll keep on moving until, once you've reached the point where there's an equal amount of matter every way past the center, then it will stop. So that's the less being forced to equalize itself by the greater. Aquinas explains this in his commentary on the De Cielo. If the only heavy body in the world were one stone dropped from on high, it would have to keep falling until the center of the stone touched the center of the world. This would be because a greater part of it would repel a lesser from the middle until an equal heaviness should be everywhere found. It's a sort of equilibrium argument. You need an equal quantity of matter on all sides of the center of the universe, and then the object won't fall anymore.
There's a little bit of scientific validity involved in that.
Sorry, there's...
It's slightly valid.
I think it would be true.
Yeah.
Yeah, and isn't that the reason why I don't know much about astronomy, but I think you start with a large cloud of gas and it sort of keeps attracting to itself until it sort of forms a spherical object, doesn't it?
Yeah.
That's
much
as I know. Okay, there is an objection here that Mercury, and Ev on the level actually mentioned Mercury, and I wondered where he got that from. So I wonder if he knows a bit more than he lets on. Vitruvius says Mercury. Sorry?
I seriously doubt that, but
okay. But he did mention the mercury, and he did say it's a liquid on which less dense metals. So copper will, I think, will float on mercury. Vitruvius sort of discovered that in 3rd century AD, I think. So perhaps the Earth is floating on some very dense liquid, which would mean that proposition 2 is false. But the problem there is that Mercury, for Aristotle, is a kind of Earth. So, if the Earth were resting on or suspended in a sort of tortoise, a turtle-shaped sort of bit of mercury, why doesn't the whole thing fall? You'd have another turtle to support that, and supported by an elephant, and so on. So the problem still remains, even if the Earth is suspended in mercury. Plus, the Earth is bloody obviously not floating on mercury, is it? Not that I noticed. Right, so we've reached the end of that first part of the proof. Aristotle has proved, just from a few simple observations, that there must be a single point, i.e. a center. Oh yeah, I presented this idea to the Bevians on the level, and they said, oh well, that means that a rock will fall towards its center. Which is true if that's how you construe it. Whereas Aristotle is saying there is a single point towards which all heavy bodies fall, and that we can call the center, because everything falls towards it. And his conclusion is based on just two premises. One, the Earth itself is a piece of Earth in midair, but two, the Earth doesn't move but stays still. So the next part of the proof, the second part of the proof, is from this conclusion, plus one other assumption to prove that level is not horizontal. People will object, as people already have done, that Aristotle doesn't use the words level nor horizontal. And, well, of course he doesn't, because he was an ancient Greek, and he wrote in ancient Greek. He didn't write in English. He didn't have the word level or horizontal. But, as you're going to see, if you define level as what the surface of standing water is, i.e. standing water is level, and horizontal as what a surface perpendicular to a vertical is, you will see that what Aristotle is saying coincides perfectly with what is meant by level and horizontal. I'm sure there'll be a load of disagreement about this, but if we work through the proof, it's clear to me we are talking about exactly the same thing. And here is the text, which is translated by Leggett, which is a really good literal translation. Literal meaning you've not bothered to finesse the translation, just make it clear. You're just saying you will literally translate every word you see in the ancient Greek into the corresponding English word. Okay. The surface of water is like this, i.e. is spherical. This is in the context of a passage before where he's talking about being a sphere. We'll take it as an assumption, one, that water is such as, perfuken, has such a nature as always to flow into what is more hollow, one, and two, that the definition of hollow, and this is important, the definition of hollow is what is nearer the center. If that is true, then he goes into a lovely geometrical proof. Let the lines AB and AC be drawn from the center. So if you see that diagram there, you've got A being the center. Someone will object that that's a circle, not a sphere, but we're looking at this in cross-section mode. Let A be the center of the universe. And draw a radial line AB and AC. Then he says, join those two, the circumference, by the line BC. So you now see AB, the radials AB and AC, and the chord BC. Then he says the line AD drawn to the base then is smaller, elaton, than those from the center. The distance AB must be, and I think Euclid, it might be 3, 2, I'm not sure. Euclid actually proves the same thing. But remember, Aristotle's writing slightly before Euclid. But it's clear from looking at the diagram that the line AD is shorter than either the lines AB or AC. Therefore, the place is more hollow, i.e. that D, in fact, the whole line BC forms a hollow under the definition of hollow that Aristotle has given, i.e. closer to the center. Every point on BC is closer to the center A than on the circumference, than any point on the circumference BEC. So it's more hollow. In consequence, the water will flow about it, or overflow is in another translation, until it is equalized. Now line AE is equal to those from the center. Consequently, the water must reach the lines from the center, since it will rest at that moment. Now, the line in contact with those from the center is the circumference. Therefore, the surface BEC of the water is spherical. So going back to the diagram, BC forms a sort of hollow because every point on it is closer than any point on the circumference. So water will start flowing into that hollow. It'll start, because the water, being a liquid and not rigid, will want to flow towards the center. So it can flow towards the center by flowing along the line from B to D and from C to D until the whole thing fills up. And then it will come to enter into an equilibrium at BEC when every point, and the water now at every point is of equal distance or equal potential from the center, and there will be no further movement. So that's the proof. The surface BEC of the water is spherical, i.e. it's level. Level being what the surface of standing water is under gravity. And it's horizontal. It's not horizontal because the line BC by definition is a horizontal. The line AE is a vertical, went straight downwards towards the center. BC is perpendicular to that, so by definition it's horizontal. Aristotle has just proved that the level BEC is not the same as the horizontal EDC. Aquinas comments on the proof. He says Aristotle proves what he had supposed. Here's another disagreement I had with the Bevians. With the people on the level server. They say that if you use the word prove, it means you endorse the proof. And they say that neither Aquinas nor Aristotle believe. They don't believe that they've just written something down, but clearly that's not true, at least for Aquinas, because Aquinas says Aristotle proves this. And if you say someone has proved something, that by definition means you endorse what they have proved. He proves what he had supposed, namely that the convex side of water is spherical, and he premises two suppositions, which are the same as the two assumptions I mentioned earlier. Since water is naturally heavy, inclined towards the center of the earth, it always naturally flows to a place that is more concave or lower. That's the first assumption. The other supposition is that a thing is more concave and lower according as it is nearer to the center of the world. And for those who dispute whether I made that up or not, you can find it in Opera Omnia, the collected works of Aquinas, in the Leonine edition, commissioned by Pope Leo, I think, in the 1880s, in his commentary on De Coelo et Mundo. Right, I think we're getting on 25 minutes. Objections 1 and 2. Right, I'm pretty sure Aristotle didn't mention either level or horizontal. I've just discussed this. Well, he wrote in ancient Greek, so clearly he didn't use the words level or horizontal. But level surface for him is by definition equipotential surface, eos and isothen. Objection 2, it's just a belief. It's obviously not an actual proof. Well, it has the logical structure of a proof. It starts with self-evident premises, the earth doesn't fall. And by purely logical geometrical steps, and that's a lovely argument, geometrical argument there, arrives at the conclusion. Objection 3, the proof is not valid. Well, it consists of two parts. The first relies on geometry to show that BDC, the horizontal, is lower than BEC, the level, i.e. it's closer to the center. Yeah, I think it's Euclid, Book 3, Proposition 2. The second relies on the assumption that water flows into what is lower. So it's perfectly valid. It takes those two assumptions and then from purely logical steps, it arrives at the conclusion. Objection 4, is it sound? Are the premises true? Well, the second argument has two premises. The first is that water flows from higher to lower. And everyone on the level and here would agree that, yeah, that's true. Water flows from higher to lower. It's self-evident. The second premise is the conclusion of the first argument, right? So there are two arguments here. One that everything falls towards a common center, or rather to a common place, which we can call the center. And the first argument relies on the assumptions, one, that the earth itself is a piece of earth, i.e. a solid material object. It doesn't have to be earth as we understand it. It doesn't just have to be dirt. And two, the earth doesn't move. Both of these are self-evident. And note, earth is in the Aristotelian sense, i.e. any solid material. Objection 5, the argument is not Aristotle's but mine, it's Bebby's argument. Bev was quite insistent on that. So this is your argument, because even if you're reading it out from Aristotle, because you're presenting it, becomes your argument. But yeah, true, he said that. You can look at the comments on his Friday video, and he says, this is Bev's argument, you've got to own it.
Oh, goodness.
True, you laugh. I think this is the last slide. And anyway, even if it were my argument, which it isn't, the argument is still valid and sound. No one could deny the logic of it, and the premises are pretty self-evident. There we are. That's it.
Excellent.
28 minutes.
Excellent. Let me close this thing. Like so. Alan, you got any questions? Anything to add?
Very succinct. I will say I do have one problem that always gets me when you start talking about this this type of logic, and that's the valid and what was the other word you?
Valid and sound. Yeah.
Because in my head, my brain understands the word valid and puts it in the position where sound should be, and it takes the sound and puts it where the valid should be.
Right. Well, couldn't
So
you sort
I
of
always
reverse it again?
For some reason, my brain always reverses it. But I guess it's just something I'm going to have to learn to cope with. But
are you know, that's just the words. Are you okay with the concepts? I mean, valid is where it's impossible. Right.
I'm fine with the concepts. It's just, I guess maybe because previously all the logic I've done has been sort of the Boolean kind.
It's Boolean, yeah.
With logic gates and what have you, because of my background in electronics.
Yeah.
And of course, we wouldn't have been that rigid with those definitions.
No, but it's a standard. It's a standard definition. I think but one of the problems we have when discussing on the level is that they will attach different meanings to the same words. Like they talk about logical statements, and I said the other day, "What on earth is a logical statement?" They say, "Oh, you're a logician. You should understand." Well, that's not a textbook term. We speak of. It turns out Bev meant by logical statement, he meant what I'd call a proposition, i.e., a sentence that's capable of truth or falsity. It's not a question or a command. So that was a confusion that could have been very simply cleared up by adhering to the common convention. So it's just about conventional terms, isn't it?
Yes, and this is my first introduction to these concepts. So I'm coming with baggage from from nearly 60 years of life. But yeah, it won't take that long before I get things the right way round for this particular uses of those definitions.
Excellent.
In the chat, I can science that. Said I may have missed it, but there was a hidden assumption there that down is to the center. Just flip it to down is parallel, and you get flat Earth.
Yes.
I've added you to the list. I can science that. And if you want to jump in here, we can talk about that.
Shall we wait for? Is that Clive? Did you say? No, I can science that.
Yeah.
Shall we wait?
Or we can go out to. Actually, we could all move to the 24/7 general chat and let anybody else that wants to join in.
So shall I close this?
Yeah, you can. There's
Who's here?
There he is. Good afternoon, sir.
Hello.
I can science that. Give us a voice check. Not hearing anything. Tell you what I'm going to do. I'm going to move everybody to.
Maybe it's not got permission.
Yeah, let's move up.
So we're going to 24/7. Yes.
Yeah, let's go up to the 24/7 and try that. There we go. And he was there for a second.
I'm going to guess he's gone away to rejoin to see if his audio will work.
Yeah, Shoebills has joined in.
Bev is a 30-watt light bulb and a 40-watt bulb. as much as 30 watts. That's not bad, actually.
No. I'd have thought more like a 5-watt pygmy bulb.
Yeah, I shouldn't be rude.
Oh, all right.
Mind you, it's got ruder, hasn't it? To be honest.
But you know, me.
Now we're getting audio.
You hear me now?
Yeah, now we can.
Yeah. Huh.
I'd have thought more like a 5-watt pygmy bulb.
Oh, you got your watch page on. Just mute that.
Right.
Boop. That's gone.
Okay.
Sorry about that, folks.
No problem. We're all in good shape now.
Yeah. So Bebby, yeah, really strong, excellent logic as always. But I did want to ask. I mean, I don't suppose any of our level folks are really this on top of things, but Aristotle's premise that water moves towards the center, or that Earth moves towards the center, seems to have been an unstated assumption. Did you cover that
No,
before?
no. Let me walk through that part of the argument again. So first, you have this. You have the observation, the empirical observation that certain types of objects fall in one direction, which you'll define as down, because everyone else doesn't, and other objects like fire sort of move in a different direction, which we'll call up. Right. So we're starting from a common observation and an understanding about what up and down means.
Mm-hmm.
Then we have the argument that says, well, heavy objects, unsupported objects, or heavy objects let loose in midair, as Aristotle puts it, fall, which we all agree, right? But if that's the case, if every heavy object falls in a certain direction, why doesn't the whole Earth fall in that same direction? And that's the problem. That's the aporia. You've got this problem, which he says that all the ancients sort of pondered about for a long time. Anaxander, Anaxagoras, they're all puzzled. You know, why do some objects fall, and why do bigger objects fall even faster? Remember, Aristotle didn't understand that all objects uniformly accelerate.
Right.
Under the influence, he didn't recognize that, but he did recognize that sort of heavy objects have a stronger impetus, if you like, a downward impetus. In that case, why does the Earth not fall downwards as well? So he's starting with that problem, and then you get the aporia, those three propositions which cannot all be true, and he solves it by saying, well, it must be that there must be a single place to which all objects fall in that direction. Because if there weren't, if all objects fell in parallel downwards, the whole universe would fall. So there must be a single point to which all objects are drawn naturally. Does that make more sense?
Well, I still say that you're still making the same assumption. If the single place to which everything is pulled is in fact a plane, then you get a flat solution. It's only saying that that single place must be a point that gives you the spherical solution.
Hang on, but if everything falls towards a plane, if objects fall in parallel, right?
Mm-hmm.
Why doesn't the whole Earth fall?
Because there is the central point to which you're suggesting everything is attracted, right?
And he's saying there's a reason for that, because if everything fell in parallel, everything would fall. The whole lot would fall. The whole Earth would fall.
But no. You're saying the only thing that prevents the fall, ultimate fall, is that when it reaches its rest point, it stops.
Yes.
Okay, so the fact that the rest point is in fact a point is the hidden assumption.
Rather than that rest, the state of rest could be in fact a line, for example, in which case you'd get a cylindrical universe, or a plane, in which case you'd get a flat universe. I'm with you. So you would get a motionless universe if the point to which everything falls is that point on the line which is immediately below it, as it were. In which case, the equilibrium will be a cylinder. Yes, is that?
Yeah. Yes. Exactly.
Yes. Yeah. Good point. I don't have any answer to that, but it would be cylindrical, correct?
If it were a line, you'd get a cylindrical. Universe.
You would, but in which case, water would sort of be uniformly cover that cylinder, wouldn't it?
Yeah, you'd have to think so. Yeah.
So level would still not be horizontal by any means.
Right, but if you take it to the next dimension and make it a plane instead of a line, now you get a universe that is flat.
I'm with you. So the whole thing drops down until it hits the plane. So let's take Aquinas. We've got an empty universe, but we'll put a rock in it. That rock will keep on dropping until it hits the plane, and then we'll stop. That's the point. That's your point, isn't it?
Exactly. And if you start with fluid only, if you drop only fluid into this universe, then it would spread out to make an infinitely thin layer, right?
It would. And
So
level
that's
would be
kind of wacky, but
level would then be horizontal, wouldn't it? Your water would float on this plane
indeed, level would indeed
to
be.
any depth you like. Except wait. Except it would have to be an equal volume of water, assuming the same density, on both sides of the plane. You couldn't have it. You know, remember that argument where he says the greater prevails over the lesser.
Right.
If the water were just touching the plane, that would not work. It would be drawn until the sort of the central point of the water would be on the plane.
Right. Yeah, you'd have to have the same amount on both sides, or
Maybe
same
that's
amount
the
of
answer.
balance on both sides.
Maybe that's the answer.
You do see from time to time diagrams of a flat Earth with a mirror Earth on the other side.
Yes, that's right. Yeah. And I think Anaxagoras had the same idea, but he thought it was flat, a bit like a pancake, but it was rotating at the same time, I think. Yeah. But we don't know much about Anaxagoras because hardly any of his writing survives.
Well, it's really interesting. I don't, like I said, I don't think anyone on the level Discord is really that with it to put that together. But maybe
That's very clever. That's
can,
very smart. Yeah.
Maybe they can clip some of what I just said there, and kind of take it to heart or something.
Oh,
what?
They'll make 2 weeks worth of a video out of that easily.
Oh yeah, that'll hopefully I'll appear on their YouTube videos next week. Get myself
the rest of the argument. What we're saying here is there are a couple of sort of thoughts inside that first argument of his, i.e. that it must all fall towards a common point, not a line or a plane. That is faulty. But that's not a problem with the logic. The logic is, in my view, perfect. It's just one of the assumptions of his first argument is questionable.
Now, remind me, didn't Aristotle already know the Earth was a sphere, though, before doing this logic?
Yeah, this is there. The first argument is one argument, that things must fall to a common point and thus reach an equilibrium. He also mentions lots of the well-known arguments. He mentions the Eratosthenes argument. He even gives a value for the circumference of the Earth. He talks about the seasons. He talks about the celestial objects rising earlier in the east and later in the west, and a couple of others. So, for good measure, he has plenty of arguments to show that the Earth is spherical.
Right. So if we're actually being honest here, if we were here debating with Aristotle, we could point out that he's made a hidden assumption that he needs to state, and he can easily back it up with the other evidence.
He will certainly do that.
Yeah. Well, that's it. That's it for me, guys. That's all I had to add.
Yeah, it's interesting to think about it. Yeah, I don't think Aristotle had any doubts about what shape the Earth was.
I think he was the first. Eratosthenes came later.
A little afterwards, yeah.
Yeah, let me just look.
I think close to the same time, but I believe
Let's look.
Eratosthenes
was he was born 100 years after Aristotle.
Yeah.
And I discussed that. I discussed his argument here quite a while ago, didn't I?
But of course, Eratosthenes already knew that the Earth was a sphere.
He knew that, but his proof does not rely on that assumption. The key point of his proof, as I think, actually I agreed with the on the level guys. the key point of his proof is that light arises from the sun in parallel, which they objected to. They said, well, the sun could be a lot closer. Now, there are other reasons why the Greeks thought that sunlight arises in parallel rays, basically for reasons of parallax. They travelled over the known world at the time, and they noticed that there is no parallax for celestial bodies. But that's a key assumption.
Well, I think simply by observing the moon, the quarter moon, in the position of the sun at that time was one of the things that led them to that conclusion. That in order for you to see the quarter moon, and the sun is virtually at a 90-degree angle to it, the sun must be a long way away.
Aristarchus, 310 to 230 BC, contemporary with Eratosthenes, but after Aristotle.
Yeah. Now, do not say that person's name more than once more.
Sorry, which person?
Because
also, I think there's a strong inference that both the moon and the sun are very far away. And as far as Eratosthenes, was concerned with, it's far enough away because it doesn't get smaller from noon to sunset. Now, even any basic object, as you walk away from it, gets smaller because of the ratio of the distances. Yes. The fact the sun doesn't get smaller through the course of the day, and yet it appears that there is some motion going on, that motion must be in such a tiny percent. Okay, it's far away. Is it 1 million? Is it 50 million or 100 million? But even at 1 million, I mean, that would be plenty enough. And yeah, Eratosthenes put it out, as an experiment in support of a hypothesis to be replicated, challenged, chastised, confirmed. So Eratosthenes didn't say, this I declare to be so. He put it out there as science. This was an observation. These are the maths. Knock yourself out, right, wrong, or indifferent.
That's actually kind of obvious, isn't it? Yeah, the sun moves around and the moon moves around. And I know they had the concept of the measurement of angular distance came from the Babylonians, didn't it? So they knew all this stuff, didn't they?
Yeah, and granted, the academics back then were a pretty small percent of the population, but for the bulk of the population, they had bigger fish to fry. They had to catch fish to live. It wasn't a question that was entering their mind or having any effect, and it was only the luxury of having academics to because of astronomy or astrology then was so important to them. They could afford to, patronize an academic to do just that, but to contemplate everything. And the one thing that bothers me about the Eratosthenes observation, the way it's been, so reported, is that on that given day he measured the angle of the obelisk, or the shadow cast by the building, or a stick, and on that given day there was somebody observed in the well, and how could they possibly do that simultaneously? Well, okay, let's put a little more logic into that. They were doing astronomical observations, and they were well aware of the seasonal maximum, the zenith maximum of the equinox or the solstices in summer and winter. I suspect he already had a table of angles from a prominent stationary object, because he'd probably been measuring that for years. He had a table. And then the observation in the well, it's not one single well on one single year on one single day. It's the wells in general in that area of Cyrene. It was noted on that they could find the solstice because on that day the reflection of the sun came all the way from the bottom of the well. And it was just that pairing in the library goes, because he knows it's the same day because it's the maximum. And he knows that the angle there is 90 and the angle here is 83, he didn't have to go out and say, oh, I better go out in the next day and measure it. He already I would like to think he already had a table of angles, and it was just the aha moment of bringing the two together. And as far as well, Cyrene isn't due south. Oh, well, and he measured the distance, which was diagonal and crude. Well, the only takeaway was at 7.5 degrees, and that was a pure meridian measurement, because had it been the reporting of the reflections off the well been even further east, it wouldn't have mattered, because it was noon there and noon in Alexandria. Yeah, that's a meridian measurement. It's not the diagonal measurement to Cyrene. And when they measured the distance by whatever mean, it was pacing or counting revs on a wheel or whatever, that was kind of insignificant. That was kind of a so what, because the takeaway was 2%, 1/50th. And since those two locations still exist, we proved, yeah, but we can check. Yeah, it happens to be 1/50th. So I don't think it was like, oh, on that day, the one-off, it was sticks. No, these were table of observations by people from, over a period of time. It's like, if somebody saw the reflection in the well on one day and it never happened again, well, no, it always happens. They know it. They always know they get the reflection off the well.
Oh, yeah, look, those guys didn't have Netflix, At night when the sun went down, they didn't have anything else to do except look up at the sky. But they knew very well what day of the year the solstice occurs on. They knew that.
Right, and it was just a pairing. It was just a pairing of, someone said, that is an angular measurement. So that was the aha. And someone said, well, yeah, but the sun's got to be pretty damn far away. Okay, then that would imply about 1/50th of the circle. We're not even applying a scale to it. Oh, what was the Egyptian stadia back then? Oh, it could have been 5,000 leagues or 50,000. That doesn't really matter. The 1/50th, that's the takeaway. The 1/50th.
Just a couple of points there, Shupil. One, I'm going to be pedantic. There was no well. That's apocryphal. He actually, if you look at the text, it was a sundial he used, a gnomon, a shadow of a pointer. But that's being pedantic. But the other important point is you cannot measure by pacing the distance from Alexandria to Syene, because you're walking across sand, and the only way to get there was the Nile. So scholars now think that Eratosthenes actually just used sort of known travelers' maps and maps of the known world, and sort of he really guessed that measurement of 5,000 stadia.
Which was, that's why I said that the distance was so insignificant for someone to carry that forward with the irregular units. But I think there was, the merchants had a pretty good idea of, that's a 50-day walk. Okay, that gives it a scale.
I think the important thing really to understand is that he was just the first one to do the measurement, and whether he even existed and whether he did it or not isn't really important. It's just we tell his story sort of to glorify the idea of coming up with his ideas.
It's a bit like Newton and the apple tree. I don't think that ever happened either, did it?
Right. I mean, maybe, right. It's not important, because the finding is there for all of us to do again. Yeah. We can do it with great precision now. So there's really no point in arguing about whether Eratosthenes' precision was good or what precise method he used. I mean, unless you're just really, really interested in the history. If you're interested in the factuality of the science, his name is glorified because he was the first one to think it up, presumably. And we celebrate that. We celebrate people who came up with cool ideas. Not that he proved something and that's why we believe it, right? We don't believe that the earth is round because supposedly Eratosthenes did this thing.
No, what is actually interesting, but less sort of story-like, is the is the history of what happened after that. Cleomedes in 2nd century AD, like 400 years later, actually wrote down what he thought Eratosthenes did. And we don't really know what happened in between those dates, or, as you say, whether the guy existed. But then the story of Greek mathematics and geometry and astronomy going through to the Arabs with increasingly refined measurements of all this astronomical stuff, which takes us to the Middle Ages and then the scientific revolution. That's the real story, but it's sort of more complicated and less impactful than that story of the Cyene and the well, isn't it?
Bebby,
Yeah.
Well, I
you
think
said
that,
that.
and again, I think the well observations may have existed along with sundials, and it was in aggregate that this is a repeated observation. Yeah, that's when the sun is zenith, and even the
Yeah.
peasants can tell that that's a given day without having sundials. So I think it was well logged, and it was the aha moment was when Eratosthenes put those two together and said that implies that's a 50th.
Bebby, why are you so sure they can't pace across sand? Because it's not as though it's blowing about. You only need to be able to get from A to B and just simply know that the distance between your paces
Well,
is a
It's
certain
a
unit.
meander. It's a meander, and then you have different people with different paces and the counting methods, and then carrying forward what is that unit of length. Yeah, you could come up with an itinerary map which would say these distances are a day long here, day and a half there, 4 days here, 4 days that, and someone can give that kind of a scale, but it's a meander, and they don't even know how meandering. They don't know how far off
yes.
line that is. It's completely without value other than, yeah, if I were to get on my bicycle and from here pedal to Chicago, yeah, I don't really need to know the distance in miles. I need to know the distance in days.
Yes. If you read Strabo, who was quite a bit later, but he shows the same technique. It's just his geography is a huge list of the distances between places. Now, if you put all these distances together and then sort of triangulate them, it will soon become clear which distances don't make sense and have been made up or exaggerated or distorted. So they were gradually building in this picture from different sources. I remember the geographer will probably not have visited these places. He or she, probably he, is just taking information, as you say, from merchants, travelers, other sort of people, soldiers, the military, putting them all together in a way that makes sense and probably coming to something that fairly closely resembles the truth. But the idea of someone pacing this distance out in stadia from Alexandria to Syene is just implausible in my view.
Well, it's insignificant. It gives it some magnitude of it's about, but the 150th, that's where the smart people carry forward, because that's the part that can be checked and that's the part that is true.
Yeah.
And the other is subjective and implied. It's insignificant. It's fine enough to say, yeah, it was roughly that kind of length.
Sorry, I missed this 150th, Larry. What are you talking about there?
Well, that
1/50 of
is
the
the
circle.
angle measurement from Syene to Alexandria. If that's a meridian measurement, so it didn't matter the longitude of Cyrene. It's a meridian measurement, and he got 7.5 degrees or 7.25 degrees, whatever. 1/50th of a circle. Because I don't know if he was using degrees or even degrees. No, he used a fraction of an arc.
Right, but if you want to find the radius of the Earth, you need to multiply that by the distance.
Yeah, but
Yes.
he wasn't necessarily looking for that. He was
okay.
just he was initially piecing together the fact that, yeah, that is about a 50th. Now,
right. So you're just simply saying it's
that is in
1/50th of the. You're just saying the important point was it was 1/50th of the circumference of the Earth, and the distance is another issue entirely.
Well, yeah, well that's secondary, and to be fair, in like all of surveying pre-electronics, distance was the toughest thing to come by. But in all of surveying, angles are theoretically achievable. Distances are not. That was so difficult, and they kept refining and refining, and all they could do was just make improved analogs. But angles have a different theoretical satisfaction that can be had.
Yeah, I mean, I suppose it's nice to know you're 1/50th of the if you go 50 times, you'll come back to where you were. I suppose it's quite.
Well, yeah, I don't know that he actually wrote down 7¼ degrees. I'm pretty sure it was.
No, he refers to 1/50th, strictly that. That's how
Yeah,
he
which
gets
is just fabulous. And when I made my measurement with the guy in Maine and Kozlowski from Maine to Hagerstown, that happens to be very, very close to 1/50th as well. I was kind of chuckling at the fact that 520 miles to Maine from here was a really nice thing to measure, because I got like 7½ degrees to the sun with theodolites. And I wasn't measuring shadows, I was measuring the light source.
Yeah, and you weren't along a meridian, were you? You were using
that
GPS
was
to get your distance.
It was a portion of Great Circle. That's okay too, because
it means you have to use GPS to do the distance. That was all. But whereas they obviously didn't have another option, so they had to be on a meridian to know that they were along a Great Circle.
Well, he wasn't on a meridian, but it was still a meridian measurement.
Well, it was very. But they were both very close to being a meridian.
Yeah, but that was insignificant. It's still the delta latitude was measured.
Yeah, but if they weren't on a meridian, you'd have a problem. If one was, say, one was in Alexandria.
No,
yes,
Padre. No, because it's not a simultaneous measurement. It's local noon wherever that is, and it's local noon wherever the other guy is, and that difference is delta latitude. They weren't doing it simultaneous. He wasn't looking at when the sun is passing over the other location. He's looking when it's in the due south here, and when it's in the due south.
Oh, right.
there.
Yeah. Again. Okay. Right. Yes. For you, because you're interested only in you're more interested in the angle. Yes. Whereas I'm keep on trying to come to the radius of the Earth.
It's not a question of more interested. That's what's presented.
Well, no, he does present a radius for the Earth.
Well, that's what you get. And they weren't simultaneous measurements. It was local noon and south at one location, local noon and south at a different location on the same day, not necessarily at the same instant, and that gives a delta latitude.
Well, that was that's one of the premises of it. It was that the noon was simultaneous.
No,
although close to.
Wrong.
Yes.
Just wrong. Because well, they didn't know how far east or west it was, but it doesn't matter because in the forensic, it was local noon, location
they knew they were on the same meridian.
Yes, yeah, Rumps is right. They knew. Well, actually, they're slightly wrong, but
they're slightly wrong.
One of his stated assumptions.
No, they didn't assume it. They knew.
One of the stated assumptions of the argument is that Syene and Alexandra are on the same meridian. He actually says that.
Okay, but the fact that they aren't did not induce error.
It is small error.
Yes,
they are very close to being a meridian, and it generated a small area. But the error was very similar to the other area about the other. Yeah, yes.
If I could inject for just a second. They had no radios in those days. They had no way to do anything simultaneously. The concept.
Yes, they did, because they knew the noons were similar because of observations of eclipses. They knew they were on the same meridian.
Okay, hold on.
I said that first.
Okay, let's look at
you
two
did.
ways.
Yeah, you did indeed.
Okay,
You found I'm reusing it. I thought it was
One at a
fantastic.
time, guys. Come on now.
Okay,
Serious form of flattery is imitation.
Can we look at it two ways? What if they are exactly on the meridian, and what if they are displaced and they're not on the same meridian? Will the results be any different?
But they were close to being on the same meridian. Yeah.
But that's insignificant. That's insignificant.
No, it's not. If they were at 45 degrees, for instance, if one was in Alexandria and the other one was in, say, in Chad, then the distance would be whatever that is, a square root of 1.4 times the distance. So therefore the distance.
No, that's why the distance is insignificant. It's a delta latitude only.
No, but hold on. He was trying to come up with Bebby, correct me if I'm wrong, but he does try and come up with a distance for the radius of the Earth, does he not? Or circumference of the Earth.
What he carried forward. what
Right.
he
So
did-
he's
what-
so that
no,
would not be
what's very
valid in your
different.
case.
What he carried forward was 1/50th.
And
No
then he
linear
came up
unit.
with and then he
That
came
was
up with
secondary.
a circumference
And
of the
that's
Earth
the
based on the distance.
You'll
Okay,
end
and
up.
we can discount that. We can ignore that. And the 1/50th.
No, we can't,
is
because he's
part-
trying to come up
yeah,
with a circumference of the Earth.
no, because the 1/50th is still true, and that's what he hung his hat on.
But then
No, but the
combined with the
five-
distance, which had to be along a meridian, you then end up with the
Yes.
circumference of the Earth.
Okay, yeah, that's
Bumpers is
why
right.
that's why it's
It has to be
discounted. That's why-
5,000 stadia.
Guys, can
Yeah,
we not
that-
talk
that-
at the same time? Come on now. Let's share the mic. Somebody go.
Yeah, the linear length. Yeah, that's the so what. That's the part that's not hardly worth carrying forward. The point I was making is if they were on the same latitude, or the same meridian, you get
Longitude.
1/50th. If they're displaced in longitude, you still get 1/50th.
Yes, but you don't get the radius or circumference of the Earth.
No, right. That's why I said the 1/50th is the part that's carried forward with integrity.
And I was saying, well, he does produce a value for the
And I-
circumference of the Earth, and that
and I-
would be invalid if he was not on the same meridian. He would not be able to come up and say,
Yeah,
this is the radius of the Earth, or this is the
Okay.
circumference. He did do that, so he wouldn't have been able to do that if he had not been on the same meridian.
Can I just give one thought here? If suppose Alexandria was way over in England or something, and you got the distance, and you knew the distance from Syene to England to London, that would be something like excuse me, 10,000 stadia or whatever, 20,000. You'd be multiplying that by 50 and getting a totally wrong value. You have to have 2 points that are known to be on the same meridian. That's the force of the argument.
Exactly.
However, had they been displaced, okay. Take for instance when Blue and Bob did it. They're displaced in longitudes, and they were only looking at local noon at that location and local noon at the other location with a delta latitude.
Yeah, but you had the distance along a great circle which you worked out using GPS.
Okay,
No.
guys, it's cool. We get it, right? If they assumed it was perfectly north-south, and they measured the distance, and then when they plugged that distance in, if it wasn't perfectly north-south, then they actually plugged in the diagonal distance instead of the north-south distance. That's what we're arguing about, right?
Right.
That's,
Yes.
you have
Does
it.
And that's why
anyone-
the one.
Does
Yes.
anyone
Yes,
think
that's
that-
obvious. That's indeed obviously what we've been arguing about. But the point is that
Then
they
we can let
are
it go
north
now.
to south. They are on a meridian. They are very close. You can ignore the error just for the purposes of for the practicality. And they needed it to be close to being correct
Yeah, if
for
you're-
them for Bebby for Eratosthenes to come up with the value for the radius of the circumference of the Earth, which he did, and he wouldn't have been able to do that had he not been sure they were on the same meridian or close to being the same. Obviously, there's an
There is no-
error in there.
There is no disputing.
In the preponderance of diagrams, I only ever see the 7¼ degrees. And that is the part that's carried forward. That is the part that is accurate. And that is the part that is insignificant to the longitude.
Yes, but he also comes up with the value of the circumference of the
That's
Earth,
okay.
Larry.
That's okay. Yeah, that's
But
okay.
he wouldn't be able to do that if they weren't on a meridian. So he specifically chose that for that
Yeah,
purpose.
okay. Yeah, but the 7½ to the 7¼ degrees, that's the part that's carried forward. He came up with a secondary approximation, which we know to be, insignificant. Okay, but the 7½ degrees or the 7¼ degrees, that's the pearl. That's what's carried forward.
Well, I think that having the circumference of the Earth is quite important, and you wouldn't get that unless it was on a meridian.
Okay, enough of this subject.
I don't know why you think that's not important. I think it was the first measurement of the circumference of the Earth and the radius of the Earth, and you're saying, well, actually, that's not very important.
Yeah.
It is not very important.
I'm with Rumpus.
Okay, all
here.
right, well, okay. Perhaps you don't think it's
No, hold
important
on.
then. Okay.
Yeah, the 1/50th was the important part. Let's just keep that.
Well, I think having a distance in units of meters is quite, or stadia or whatever it is you want to have, is quite important.
Well,
I'd say if any of those assumptions fails, like same longitude, same angle, the angle of 7.2 degrees, and what was the other? Parallel right rays, then it fails. He also appeals to Euclid proposition 129. There are 6 assumptions altogether. And if any one of those fails, then each of those is a necessary condition. Then the whole argument fails.
Although,
And
if the
what-
longitude is different and you're not dealing with a simultaneous measurement, and they were not dealing with a simultaneous measurement.
Yes, they were.
No, they were dealing with local noon at each location.
And which is at the same time. The local noons at Cyrene and Alexandria are at the same time, as far as we're concerned, within a reasonable margin of error. That's the whole point. They were simultaneous.
It doesn't matter. Their clock, they made no attempt to synchronize. If they were even attempting to make a specific observation, they made no attempt to synchronize their clocks. It was local noon, make your observation.
But because they knew they were simultaneous, they knew they were simultaneous, they could then use the distance measurement north to south along a meridian.
The distance out, would you please? It's a delta latitude. It's a delta latitude result.
It's a radius of the Earth result, or the circumference of the Earth result as well. And you seem to be ignoring that bit completely. It's at least as important.
Yeah, I'm carrying forward the 7 1/4 degrees as being the most important fact brought forward.
Well, I think the circumference of the Earth is more important.
I'm wondering, Bebby, you've done some research on this, haven't you? It's the way I was always told the story is that the uniqueness of the experiment or the procedure, whatever you want to call it, was designed to calculate the radius or circumference of the Earth. That's what he was bringing to the.
That was the purpose of the experiment, whether or not there was an experiment, because it's a story.
Whatever we want to call it.
Later, right?
Right.
Of that narrative, the whole point is to prove the circumference of the Earth in stadia. Aristotle mentions the same or a similar experiment. He wanted to know how large the Earth was.
Exactly. That's the important bit.
They knew about angles from the Babylonians, who first developed these sort of instruments to measure angles. But the idea of Eratosthenes' experiment was to determine the very size of the Earth.
Yeah, Flat Earth Math mentions in the chat that they're a few degrees off. We know that. We mentioned that before, Flat Earth Math. Yes, we know that already. Goodness gracious.
Well, he was trying to be helpful.
No, he's not trying to be helpful. Well, he's not listening.
He's not. Right.
Perhaps he hasn't heard the other stuff.
Yes, I'm just playing on Google Earth right now. And if you went due south from Alexandria to about the same latitude as Syene, which is near Aswan.
That's right. Yeah.
That's around 492 miles, something like that. The diagonal distance is around 525 miles. So, your distance is a little bit different.
Yeah. Fortunately, though, the error that way round actually was compensated for by the error in the distance. Yeah. So they actually sort of slightly cancelled one another out. The distance they believed it to be and the error with the slightly difference in longitude, they actually counted one another out, and then meaning the result was actually slightly better than you'd expect.
So they were within about 3 degrees of being on the same meridian.
Yeah. So
don't forget they were both
not off a mile.
They were both observing that there were local solar noons, so that difference is very minimal too.
Yeah.
Yeah.
Yeah, 7.5 degrees.
Just to repeat something I said earlier, the result that he got isn't really that interesting to us anymore because we can get it down to the millimeter, with modern technology. So what was interesting was the idea of going through the experiment or going through the exercise.
Right? Yeah, I mean, historically, obviously, sorry for interrupting. Carry on.
And it's also really kind of interesting that how good he ended up getting, how remarkably close he was, presumably, with such primitive techniques.
I mean, this is the classic thing that flat earthers like Bev and others, they always are, and also religious types, they always seem to think things like the Bible because of the originality. That's the important thing, the original measurement, and you'll often get flatties and things talking about the originals, as you like this with Aristoteles, they're obsessed with it, whereas as science correctly says, the rest of those of us who are interested in science are only interested in what's ready now. We're not interested in the fact that Newton, we know that the Einstein superseded Newton. We're only interested in the up-to-date, absolute up-to-date state of science and the position then. It doesn't matter what even Newton, we could eliminate Newton now and it wouldn't make any difference to what we're doing now. We obviously historically it might do, but it would not change anything about what we understand about how the way the world works.
So Rumpus, do we not learn anything? I'm passionate about the history of science and not really much about what science is now. What do we learn from the history of science?
Well, obviously it's educational in terms of how knowledge is built on knowledge, and that is interesting. I'm very interested in history, and I'm very interested as how accurate Eratosthenes was. So I find it very interesting, and obviously the fact that Blue reproduced the exact technique as well, and Larry did the same things. I think it's absolutely fascinating. We can do, and because it's so practical, you can do it yourself. Larry and Blue together have demonstrated the radius of the Earth from very basic measurements. And so from the history, I think it's obviously fascinating what we learned before, what we did, and the consequences of learning those things. So that's absolutely fascinating. But in interest in science, you're only interested in what was discovered yesterday, or because science is always provisional. And it's always going to be most things. Well, it also has to be compatible with what's happened historically. So, for instance, Einstein's theories had to be compatible with what we measured in Newtonian type experiments. But basically, we're only interested in what happened yesterday and what's accepted yesterday. Whereas flatties and religious types, they're always going back and saying, "Well, hold on, what if Newton said this? Then doesn't that affect you?" No, it doesn't. We're only interested in research that happened yesterday.
And in 1760. 1750, 40, whatever, when the Academy of Sciences determined the ellipsoid, when they performed essentially an Eratosthenes across France and an Eratosthenes in Finland or Lapland and an Eratosthenes in Ecuador.
But the point there,
so that is the method.
The point there is they had much more accurate methods than sort of pacing or traveler's stories. They literally got a gigantic chain to measure a baseline, and then by triangulation just measured a whole portion of the arc. I mean, the sophistication of that was awesome.
Yeah, it was technology had advanced. That's why in their Eratosthenes, I said, that distance, that's not the thing to carry forward. The thing to carry forward was 1/50th. And the distance was the flexible part because distance is elusive. Pre-electronics and pre-technology, distance was very elusive.
You have a point there, and there's a kind of puzzle there that a lot of people, particularly in the flat Earth community, don't understand. Is that there are two ways of measuring distance. One, astronomically, but there you have to assume the Earth is a sphere because nothing there will tell you whether it's a sphere or not. The other is sort of measuring it along the ground, which you do with triangulation. These are two quite different methods, and what Gauss got out of that and non-Euclidean geometry is just fascinating.
And that's why when describing zenith angles to celestial bodies, the term carried or attached to that is called a zenith distance.
I've just got to quickly respond to Sean Hawkins going bonkers in the chat about my comments about Einstein superseding Newton. If you want to know the orbit of Mercury, Sean, you have to use Einsteinian mechanics. You cannot use Newton and get the right answer. So in that regard, there are areas of the universe, although 99% of the universe you can use just pure Newton to get things right. You need to use Einsteinian stuff.
Why is he going bonkers?
Well, he claims I'm wrong, and he's saying, "Why isn't anybody?"
Sometimes you are wrong, Rumpus. It does.
No, it's not. That's not happened. That doesn't happen.
It does.
Like a word.
No, it doesn't happen.
Don't use the word supersede, basically.
Well, it is correct. Well, it has. I mean, the Newton's laws are a subset, a derivation, a special case of Einstein's laws.
Yeah, but
and gravitation is an acceleration due to geometry, and but it just so happens that it resolves into a force which is compatible. Because force F is equal to ma. You can either have an acceleration or a force, and it doesn't really matter which. And the factor which connects the two is the mass. So if you have an acceleration, you end up with a force, and so you can't really tell which of those two you've got. and Einstein says you get an acceleration from the geometry, and Newton said you start off with a force, and Newton was actually wrong. But we can use those equations and get the right answers in 99%, and NASA can do it if they want to take some probe off to flipping Pluto or something. They can use the Newtonian stuff, but nonetheless, the Einstein stuff is correct, and the Newton stuff is a special case of it.
Can I just
Right.
pick up something else that
when you say
Flat Earth? Hello, Flat Earth Math says. Sorry to slightly change. Well, to change it back to what we were talking about, the history of science. Flat Earth Math, which is Charles, I think, isn't it? Says the history of science is a fundamental facet of the study of science. Shoulders of giants. Yeah, I would agree with them there. It's the thought process that science, the human mind, goes through, which is important. And it'd be interesting we get Flat Earth Math in here, because I think it was him who said in one of his presentations that it was a good thing that Aristotle prevailed over the atomists of Democritus and such like, thereby delaying the progress of science for 1,000 years. And I've always thought about why he said that. I wonder if you can we invite him in here?
Yeah, you can argue that getting things wrong for a long time does enable a position where it can then be revolutionized. So the autonomy stuff. Whereas if you had something was almost correct, so if something like Newton's, for instance, was so close to being correct that it stayed the same for 300 years and took a long time for us to refine it. So if you have got something that's really, it's a bit like actually the metric system. In France, they had a terrible system of measurements. And so because they had to fix an appalling state of affairs, they then ended up with they then created a whole new marvelous metric system, which was rigorous and brilliant. Whereas in the UK, we had a system that was pretty good and went round the world, but inches and feet and everything. But it was sufficiently good and established that it worked reasonably well. And then it took us a long time to then become metric. So you can argue these jumps by being absolutely appalling. You can make bigger jumps in some ways.
There's something to be said for that. Also, we got SE Montreal here. Well, he's in the chat, but he's not. Is he allowed in here?
I'm not sure if he's in the server or not.
No, he's in the YouTube chat.
Yeah, I see him in the YouTube chat.
I just wanted to ask him whether he's now persuaded objects do fall.
No, Yogi is a pretty ignorant person, so.
Who is?
Yogi Bear, SE Montreal.
Right. Flat Earth Math says in the chat, I'm not sure what Bebby is saying, and I missed the first hour today. About Aristotle. Maybe he's quoting someone else. I'm sure it's Flat Earth Math who said it was a good thing that Aristotle prevailed over the atomists. But I never quite understood. I think it might have been that if the atomists had prevailed, then we'd have nuclear war in the sort of the 3rd century AD, which would have been a bad thing. But then it didn't quite follow that logic either.
Actually, although I said I'll never get anything wrong, just to quick that, Larry actually last time I was on a hangout here, he actually slightly revised my position, the terminology I was using.
Well, you're wrong then. You were definitely wrong.
No, I wasn't. But I revised slightly. No, I wasn't.
Nerd Alert says he's talking about the precession of the perihelion on Mercury, which is not that much. 1% would be a hell of a lot, actually, couldn't it?
Actually, Nerd Alert actually may have given me it's Truth Nerds, actually. Sorry, there's some guy called Truth Nerds. When I was talking about dimensionality of things in the last hangout, I said that you could, a line has one dimensions, and I therefore said you could describe with just one thing. And there's a big post, I think, on Blue's thing saying it gets really aggravated by people saying this, and there's some topological argument as to how you can determine the dimensionality of something, and that I was actually wrong. So
is that what Nerd Alert says?
No, I think I'm getting mixed up between Nerd Alert and Truth Nerds, I think, or Truth Nerds. There's some guy, so Nerd Alert, I think it's but it was a comment. So that could be the case of me being wrong.
Nerd Alert knows a lot about dimensionality. I was having a chat with him today.
Oh, perhaps it was Nerd Alert. No, I thought it was Truth Nerds. Perhaps, yes.
Well,
someone
it could be both. Perhaps they both know.
Yes, okay.
Flat Earth Math says, no, it wasn't him. I must be confusing with someone else. But yes, I think I am. Yeah, there's a guy called Matthew Learns or something like that. He was on Bev's the other day, and he gave a very good presentation. Not that the Bevs really appreciated it. Anyone know who Matthew is?
Sorry.
No.
Yeah, I think I've heard the guy.
Yeah,
But
there's
I
a
don't
big
know who
argument
he is.
going on in the chat.
I'm
Sean,
afraid Sorry, go on.
Sean is saying that you're very, very wrong.
Well, I'm afraid I'm very,
Was
very
he
right.
saying that flat Earth math is very wrong? It's very hard.
Oh, I don't know.
This
Time
place
Oh,
is
they're just playing.
there's as many
point
arguments here as there are on the other channel.
Yeah, the point is that Einstein describes what's actually happening, and Newton's is a very, very useful approximation that works
Well, there you go.
really, really well.
I would say that Einstein's is a somewhat better approximation, but to go out on a limb and to say that it's correct
That's good point. Good
would be
point.
presumptuous, wouldn't it?
Yeah, you're right. You're right. Yeah, I agree with that.
So, with that in mind, that means Newton is clearly not wrong. He's just not as accurate or as general. Perhaps.
Oh, no one said he was wrong. He's just as you say, an approximation. I think I said that 10 minutes ago.
You said he was wrong.
Yes, but that doesn't. I was just speaking to.
Did I actually say the words wrong? Okay, well, I said the wrong. Okay, I did say he was wrong about if you wanted to get the orbit of Mercury correct. I suppose I did. Yes, I may have said Newton's wrong if you wanted to use.
And how wrong was he? It wasn't like some 1%. It was like a couple of arc seconds a century.
Exactly.
43 arc seconds. 43 arc seconds a century.
Yeah.
Yeah.
So,
out of 5,700.
yeah, but if you want to do anything near a black hole, don't want to use Newton. It's going to be very wrong if you start, having very fast things, or you start moving near a black hole or something. So Newton's equations will go down the toilet and become very, very wrong, whereas Einstein's will hang in there for a bit longer until, of course,
Yeah.
I mean, Einstein in the middle of a black hole, even Einstein's equations, as I can have sort of effectively implied, they will collapse then. We need some sort of quantum version of gravity to explain what goes on inside black holes. But yeah, so Einstein is the latest, best approximation.
And the impressive part about 43 arc seconds per century is they didn't spend a century to measure that. They determined that, of course, across a couple of decades, which means a fraction of the 45 seconds.
Yeah. Indeed, it's very impressive. They knew it to that resolution, and that it was an issue when Einstein was chatting.
So Rumpus Flat Earth Math says he will not come into the forum with you, and that you're always wrong.
Yeah, but he's always wrong. I mean,
Not
he doesn't even understand
he
doesn't even understand that geometry is prescriptive. He doesn't even understand the difference between science and maths and geometry.
I remember that.
I mean, God, he got back. I mean, you agreed with me, Bebby. You and Larry agreed with me when I said he was wrong about that. And he just completely ignored that in his sort of flat earth, sort of conceited manner. He just sort of said, I'm going to ignore the fact the rest of the panel disagree with me and provide me an argument. I'm not even going to provide a counter argument. I'm just going to assert that what I believe is correct. Geometry is prescriptive, and people use different geometries to describe the world. But the geometry itself doesn't have any. He said maths is wrong. No, maths is not wrong. Geometry is defined prescriptive. There's no part, and he said it was derived from the real world. No, it isn't. There's no part of Euclid or any mathematical thing go into the real world. And if flat Earth math knew the difference between a priori and a posteriori, he would realise he cannot possibly be correct. Oh, idiot!
He did tell me that logic was perhaps not his strongest.
Yeah, well, he
point.
demonstrated that, and not even understand the basis of geometry and maths is a bit shocking. Well, I'm sorry, he's just. He annoyed me then, and he got so conceited and sort of started disparaging
That's
me.
Enough of that. That's enough. No.
Okay.
Yeah,
all right.
We don't need to go through that again.
Okay, we don't want to go through that again.
Anyway, so it's Einstein. Go ahead.
The beauty of Newton was he broke free the first time from that idea of this objects falling to a center, and there being a center to the universe. That was a real revolution. The idea that actually the Earth has its own gravitational field to which objects fall because the Earth is there. Jupiter is the same, but it has its own center to which. And then he explained orbits. I mean, that was just one of the greatest leaps ahead, greatest leaps forward in the history of science. No, doesn't matter if he was wrong slightly about something that Einstein.
Absolutely, he's brilliant. Yes,
he is. Although he wasn't a very nice man, actually.
No, he was very nasty.
He's a very bad man.
Yeah, but though
flat
it's
Earth
amazing when you
first.
hear this history. I mean, people like Galileo. I mean, this idea, this law about moving in one dimension, and won't keep going moving in a straight line without any force, etc. I mean, that Galileo had stated that, but Newton was the first one to put the. Yeah,
I think
I think it was
you're
Galileo
right.
who was the first one to state that, but he was certainly one he did state. I can't remember if he was the first or not. So there's another history of science for you. And Newton, but then obviously Newton made up the laws. I mean,
I
I think
never
even
used.
someone else knew that forces equal to ma almost described it like that. I think
Yes, I think
Bacon
even
had.
some of the medieval calculators, the Merton calculators, came up with something like that, but always
Was
hard to
it Bacon?
tell.
Who was the head of the Royal Society when Newton was the first one?
That would be
Was it
Francis
Bacon?
Bacon, would it?
Yeah, Francis Bacon. Yeah, he
Not to be confused with Roger Bacon.
indeed. I believe, has stated that he knew that force is equal to mass times acceleration. So, although we say Newton was brilliant, and obviously he brought it all together, and realizing that something like dropping this theoretical apple dropping on his head was the same force that was holding the moon in place is obviously fantastic. But it's amazing. All these things we seem incredible. I mean, the Einstein things. Even then, there's quite a lot that was leading up to it that was, well, the quantum physics, particularly in the 1920s, when you see people, the Schrodinger's wave equations and things. There was lots of wavy equation type stuff that came before that, and there's what you're asking historically how science works. It's surprising how many increments there are, and the people we give credit for these big jumps actually. The jumps aren't as big as they seem if
They
in the
very
context.
often there was an atmosphere going around at the time. Very
Yes.
often, a lot of people talk about this, like non-Euclidean geometry. There were three major figures who came up with it at very similar times. But as you say, someone will draw it all together, or just drag their way into it, or just present things in a way that makes more sense. Yeah, I mean, Boyai. He got published because he got something published in his father's. His father was a school teacher, and he published something at the back of this sort of textbook that his father published. Otherwise, it would have been totally forgotten, sadly.
Yeah, so the history of science is a lot of very small increments, and then some little clever chap will just take everything to collect everything together and say, "Oh, look," and then go, "Oh, yes." Though I must admit, Einstein with the great that was a big jump actually, because he spent 10 years trying to write the formulas for general relativity, and though he had to call upon. I mean, he called upon the manifold, the actual shape and geometry of it was all based upon Riemannian force space, and he basically just used that to then get the result. And although he spent 10 years finalizing everything, and there was a lot of things in place for him to do that. And if he hadn't done it, presumably someone else would within a couple of years.
Okay. Are there any other? I have to go in about 10 minutes because my battery again. Are there any other? Are any other comments on Aristotle's proof that level is not horizontal?
And of course, we shouldn't mention Aristotle knew that the Earth was. He saw the shadow of the Earth on the Moon in a lunar eclipse, and of course, he commented on the fact that master ships went low below the horizon.
Yes.
So he obviously
That
knew.
that is the shape of the Earth. This is about level and horizontal, which came as a complete surprise to me. That whole argument. Were you in for that argument, Rumpus?
Sorry, I missed that. Apologies.
Right. So you missed the whole presentation then.
Sorry, I did. Yeah, I wish I'd get can I get notification of these things? I must have didn't.
No. I did advertise it, but
sorry, Bebby, I missed that. I've been a bit.
Well, you can see it. You can watch it tomorrow. But there's just this great geometrical argument to say that water will flow water will flow to a place that's lower. Then if you draw a chord, every point on that chord is closer to the center of the Earth or to the center of the universe than anything on the perimeter, on the circumference. So that's perfectly straight chord is like a hollow, which the water will continue flowing until it fills it up to make. So it's on the circumference. So it's on the surface of the sphere.
Equipotential surface, right?
Yeah, and he even uses the iso in that to the Greek. It follows that.
Oh, really?
Yeah.
Wow. Okay. Sorry, Bebby, for missing that. Apologies. I will watch that tomorrow.
I'm sad. Let's have a look. I've logged out now, but if you watch it tomorrow, it's a beautiful geometric argument, which on the level people love, right? And it's by Aristotle, who they love. And it proves literally that level, i.e. an equipotential surface, cannot be the same as a horizontal surface. It's genius.
It was fantastic. You do need to scroll back and watch that. I was astounded. I did not know that Aristotle had put all that together.
I did not know that, because this is before Euclid even. But obviously, a lot of the theorems that Euclid came up with were known before his time. Euclid again put a lot of this sort of stuff together in a brilliant way.
How did the on the level people react to it when you showed it to them?
Showed what? Sorry.
Hadn't you presented that to them before?
No. I discussed the first part of the argument where he proves about the paradox of the Earth that is not falling. I discussed that with them, which they laughed at, but they would. Then I looked through the whole of De Cielo, Aristotle. Then I found this neat argument about level not being horizontal. I thought, well, that will amuse them. I did tell them about it without telling them what the proof was, and they just shouted at me, said I was lying. They said it wasn't Aristotle's. Then they had that weird thing about, if you present someone's proof, and it's not their proof, it's your proof because you presented it, which is weird.
When were you on the level? Was that a couple of days ago? Then I missed
That
that as well.
That was wow. When was that? I think it was Friday.
Thursday.
Maybe. No, was it Wednesday? It was Wednesday.
Okay.
You actually
Sorry, I missed that one as well.
You actually went into Bev's server and tried to talk.
Yeah, I don't like to do it, but this time I went in and oh, that's right. Yeah, I was chatting with Mike Jones, who was in an even fouler mood than he normally is. No, he came in. Admittedly, it was 5 o'clock his time, but that's the time he likes to chat. And he sort of started off by saying, "Well, Bebby, I don't give a fuck." That's how it started, and it sort of went downhill from there. Yes, we got.
I mean, that's a punishment that even Sisyphus doesn't deserve, to go into Bev and try to talk to Bev about things that Bev disagrees with.
Yeah. I have this faith that logic, because it is so simple, and all the steps in logic are logical steps, right? I have this faith that you can persuade anyone, however prejudiced, but that theory is unraveling sort of slowly.
How long have you been talking to flat earthers?
You don't.
Clive Wells has got it exactly right in the chat. He understands that you apply a geometric model which flat Earth math doesn't understand.
When does he say that?
I won't harp on it. Oh yes, I'll have a look at that one as well, Bebby. That's yes.
Yeah, do look at the presentation, because it is a lovely. And I had never realised that sort of proof, which we think of as being much more modern, came from Aristotle.
Oh, one thing interesting I found about that. Sorry, if you have a question for you, Bebby. Here, I'm trying to, for my little book-like thing that I was been doing well from preparation for this Rect thing. I'm trying to do a little potted guide to logic, and I came across the fact that Aristotle didn't really only really did the syllogistic type logic, didn't he? He didn't do the propositional stuff, with the he didn't have the concept of or and, for instance, or if A then B. He didn't really do that, did he? That's the Stoics or something, or the
was the Stoics. There was a scholarly movement to discredit Aristotle, and so the Stoics were the most brilliant people that ever existed. But there is a hint of that stuff in Aristotle. Plus, Boethius wrote something. He wrote a treatise on the hypothetical syllogism, which is propositional logic. But yeah, Aristotle was definitely the quantified logic. Every none, some. That sort
right.
of.
So he didn't do the and the or the if then type lark, or the propositional stuff, right?
He does. He mentions it somewhere. I'll need to look that up. But
okay. Well, I want to do a hangout with you on logic anyway. It's for you to check my work, just in case I do make a mistake. Okay. I want you to be there to.
Not that you would be wrong.
If I would say I don't know, I'm allowed to say I don't know. I don't know everything, but I generally, if I say something is true, I've got a pretty good chance of being correct. So, but if I can get you to check my work, I might say this is provisional, in which case I'm prepared to say.
Well, you keep saying this. You keep saying we should have the hangout, but it's.
I know. I'm sorry. I apologise. I know. I'm doing Rect and everything. Yeah, I've been a bit poorly. Sorry.
I'm sorry to hear that. The back again.
Yes. Yeah. Back and angry.
Okay, my battery's nearly dead. I'm going to say goodnight. Thank you for putting up with me.
Okay. Yeah,
Thank you for
thanks,
listening.
Bebby.
And see you all shortly.
Yeah,
See you this week.
Thanks,
thanks
Bebby.
for the presentation. Enjoyed
Thank
it.
you. Good night.
Okay, now what?
Totally random. I have a question. If you guys want to talk about early research into Lorentz transformations and relativity.
Sure, let's do that.
I don't know if anyone knows this, but Lorentz, right? He came up with the transformations before Einstein published, anything about special relativity, right?
Right.
Yep.
I caught something very briefly, and I haven't had the time to really research it yet, that indicated perhaps Lorentz derived his transformations not based on light, but based on electron beams or something like that. Has anyone heard of this?
Damn it! I read up on this, and I can't. I should be able to help you here because I've read up on this, and unfortunately I can't remember. So, alas, sorry.
Just curious about that. If anyone knew the history, again, that's a science history thing, right? From a science perspective, nobody cares. But from a science history, it's kind of interesting that
yeah, because I think that really helped when you. I find that actually reading through this history and the way that people have developed their ideas is really useful to understanding it in its final form. The fact they went through, because only by rejecting things that don't work or are wrong do you actually understand fully the thing that's right. And so I think this evolution of what went before and what helps you to understand the final result. So yes, I completely agree with you. It's fascinating to see these little diversions and things that aren't quite right or so in Lorentz. And I mean the Lorentz transform. He I think believed. The crucial thing about Einstein was that the things do not change. I think Lorentz, did he not actually believe that the lengths changed within your reference frame, whereas Einstein saying no, the things remain their same length, etc., but it's just the way you see them from your reference frame to another reference frame, the thing appears to have been shortened, whereas I think Lorentz was suggesting there was a real world contraction. I think I'm not absolutely sure about that though. I might be in my sleepy state.
I'm not sure how to put my finger on the difference between those two statements, really, but I do know that Lorentz was suggesting this was an effect of the ether, that passing through the ether was affecting the length of travel.
And indeed, I think he believed that the length actually physically changed.
Yes, yeah. Well, it does.
Whereas Einstein doesn't. It's your view of something in another reference frame.
Well,
it appears to change, whereas it does not. That was the difference between them, I think.
It's sort of philosophical, but my take on Einstein's statements are that it's relative. So yes, it literally changes as you change reference frames.
Well, right, but everything in its own reference frame has underchanged. Well, I think Lorentz was saying that in the damn it, I'll have to get back to you on this.
Okay, so perhaps Lorentz was suggesting it was a change of length that is invariant across reference frames that was happening. Is that what you're saying? Like everyone's reference frame, the lengths changed.
Yes, possibly. That is possibly what I'm saying.
I'm not sure.
Or what I think he was saying.
Yeah, that's worth looking into because
yes,
I do think that the history of science is valuable to teach, and particularly we see it in the science denial folks. I don't think they really have a good relationship with that. Like, for example, we talked about like Eratosthenes, and they'll say that, that doesn't prove anything. And it's like, well, no, that's not the point, guys. The point isn't that Eratosthenes proves something. The point is that you could do this too, right? You could do this experiment and show what the results are.
Well, of course, fundamentally, science can't prove anything because it is in the real. It is a posteriori, and you never know what other effects are.
Of course.
Yeah, sorry, that's another philosophical level up. But yes, I mean, obviously, in a court of law, it would be probably regarded as proof to say that these are angles on this thing. Thing. But when we talk about philosophy, obviously, we're talking about cast iron proofs that cannot be invalidated, which is a bit different.
Yeah, but I do think that looking at at what they were looking at, and then we carry forward the data that they had. Right, we do that as long as it's still valid, as long as no one has invalidated data from the past. Anything that we come up with now must be consistent with the data from the past.
Absolutely. Yes, assuming, as you say, that data. Well, obviously, someone would make measurements. I mean, Tycho Brahe, making measurements of the angles to stars. I mean, he could have got things wrong, so we can't rely on that data. You obviously use it as a useful to you, but obviously if anything's ancient, obviously you wouldn't want to rely on it, but it'd be useful if it agrees with it. But what you obviously, like Newton, for instance, the Newton and the Einstein thing is anything. If we can establish in the current today that Newton's laws work, we have to make sure that the Einstein is any new idea of gravity or something is compatible with what we know at the moment that we trust. So yes, so completely agree with you that if you've got reliable data, we can't invent new laws which invalidate data that we believe to be correct. Yes.
Yes. The Newton Einstein is an excellent example of that. When Einstein supposedly, you'll hear he superseded Newton and Newton is invalid and Newton is wrong. Well, the moment Einstein publishes, his law must be backward compatible with everything that we've done in the past 200 years, or else it's invalid on the day he publishes it.
Yeah. And the trouble with, of course, with as I was pointing out earlier, with force is equal to mass times acceleration, Newtonian. I mean, I always thought of it. It was only 10 years ago, I realized that you can either have the force or the acceleration. We tend to think of the force as being the driving element in something accelerating, but if you've got inertial, like something like centrifugal force, which is an inertial force, you've got an acceleration which is then converted into a force. And similarly with gravity, you start off with an acceleration due to the geometry issues, and then it converts itself into a force, because obviously if you've got an acceleration, something being accelerated in your reference frame, then the force that you need to do to deal with that is to multiply that by the mass, and you end up with the force that you're going to have to either apply or it's going to appear to have. Similarly, if you apply a force, it can end up with an acceleration. So we don't tend to think of acceleration as being the driver, but it is in terms of general relativity and other reference frame based physical situations. I can't remember what I was.
I don't know. I would say the geometry itself is the driver. In GR, that's not an acceleration in GR either. It only becomes an acceleration if you transform out of 4D back into 3D. Then it appears, when you change reference frames, it appears as an acceleration.
Correct.
Yeah. Yeah, and the same as force. Same with force. Yeah, just like centrifugal force.
Sorry, what you said,
same as the force.
GR generates an acceleration, which you then manifests itself by multiplying the mass.
No.
Yes.
GR. Well, as when you're still in the GR equations, it's non-accelerating. It only becomes an acceleration when you transform out of 4D.
Yeah, into 3D. So in the 3D world, it becomes an acceleration.
Right,
yes, we agreed on that.
And that's equivalent to a force.
Yes, and so then by multiplying by the mass, you then end up with the force that is associated with that acceleration. Similarly with sorry.
Yeah, just like centrifugal.
Yeah, exactly. And so whereas we tend to think of force being driving a mass to be accelerated, you can get situations where it's an acceleration and you multiply the mass, you can end up with a force. GR as an example, centrifugal force is an example where again the reference frame change, and so that's why you can get that F is equal to ma. It's not always the force that creates an acceleration. It's sometimes for various reference frame changes and things, you can start off with an acceleration that will then generate a force in effect.
Right. I'd say that's a philosophical question again, but I think we do, because of our everyday experiences, we think of force as a thing,
yes,
when really it is not. It's a phenomena, right? It's not fundamental. Force is not fundamental.
Why do you say that? I don't understand.
Well, when you push on something,
yeah,
you think of that as a fundamental application of force, but of course that's what you're really exerting is the Pauli exclusion principle of
right.
electromagnetic, and that's not a force; it's a momentum exchange. Maybe momentum is the fundamental.
Right, but yes, I mean, but the Pauli exclusion principle that allows the Well, what do you think of the meant?
It's really philosophical. If you want to call it,
I'm not going to declare that just yet. I think it's. I think
the bottom line is, like you said,
force doesn't exist. Force doesn't exist at the quantum level. I completely agree that doesn't.
Right.
But at the macro level, I think it is. Although it might be the mechanism, might be the Pauli exclusion principle. I still think the laws of motion. I just because the mechanism it might be involving quantum thing, I still think that the concept of a force does come about as and I'm not quite sure how you get. Yeah, okay.
Here's a discussion I had with my physics professor back in undergrad. I thought of force very much as the fundamental. So when we came to the idea of let's derive conservation of momentum from F equals ma, you can do that. And that's the way I came at it. So I see F equals ma as the fundamental, force is the fundamental, and momentum is the emergent property.
Yeah.
And then, but he came from the other way. He said, no, momentum, conservation of momentum is the fundamental from which we can derive F equals ma.
Agreed. You could do it that way. Yeah.
So if you take my physics professor's point of view, then force itself is not fundamental, but momentum is.
Yes, I mean that is a view, and as I say, at the quantum level, there's force is not used at all in quantum mechanics.
Well, and when you bring in the force of light, right? You say, well, F equals ma, and wait a second, no, there's no mass.
Yes.
And yet a photon can exert force.
Yeah. I mean, but that's a different issue. That's saying that you can have momentum without mass. That's a different question.
Right. And we know that this is factual. You can have momentum without mass.
Yes, but that's a different discussion. We were talking about force and momentum, and now you're saying you can have momentum without mass. Yes, I agree with you.
Tied back to the F equals ma. You were saying perhaps the acceleration is the fundamental.
Oh no! I was saying you can have either. I was saying in certain situations, like with GR and centrifugal force, you've got acceleration as the driver effectively, and the force is a consequent. And whereas most of the time, if you're saying you gave the example pushing on something, there the force you're exerting with is the initiator of an effect, and the effect is an acceleration. So I'm saying you can come with two ways, different depending on what the context is. But I don't quite. But your argument about having momentum coming from something without mass is a different question, a different issue. About it, but...
Yeah, I only bring it up as yet another angle from which to investigate whether force and acceleration are themselves fundamental or derivative of something else.
Because you can have momentum without having mass, but that still doesn't affect the relationship between momentum and force. And then you can have force exerted by a thing, but you could argue that's coming from its momentum. So it's not affecting the question we were discussing about whether force or momentum is fundamental. If anything,
it only ties back to where you had suggested that under GR, the acceleration comes about from GR, and then from that we back out a force, right?
Oh God, sorry. Sorry, I just seen that Clive Wells is commenting, so I'm going to stop saying it. That's someone.
Right.
Yeah, Clive is the one who's definitely on the case.
Talk about
Here we
distinction.
go. Yes,
Exactly. What Clive
I
said.
don't argue with Clive, for instance. That's one of the sensible things I've learned to do. Well, I've never argued with him. Yeah. Okay. He's already confused me by what he's saying, so refer to Clive.
He's just simply he's saying in a more mathy way what I'm sort of alluding to, which is that whether it's a force or not is a semantic question. It's not a fundamental mystery of physics.
Conservation of momentum comes from the invariance of space-time under spatial translations. There you go. I hope you well understood that. That was Clive.
That's right. Yeah, as long as we're geeking out, a lot of people don't know that energy is not conserved under different transformations.
Sorry, I was just looking at a jibe from Flat Earth Math. That was sorry. Could you repeat that?
All right. Well,
sorry. Energy. Was you saying energy is not conserved in transformations?
Yeah.
Yes, but obviously something like kinetic energy. Yes, I mean if you're in different reference frames, something can have. Yes, if you're in a reference frame that's moving along with an object with kinetic energy, it has zero kinetic energy.
That's right. Which is really sort of mind blowing, I guess.
Yes, it is.
For me when I thought about it.
Indeed, yeah. Many years ago, I came across the same thing, thinking about this. Hold on, what's going on here? And yes. I agree with you. That is a bit of basically the whole issue of reference frames is a very confusing thing, and obviously it's the cause of general relativity, as you described it just now with the energy and momentum and things, and we just Blue and I regularly have this slight disagreements over whether or not what leaving a reference frame means and things. Yes, yeah.
Blue, what did you think leaving a reference frame means?
Well, he doesn't believe you can leave it, I think.
You don't. Reference frames, the most confusing thing about reference frames is that I think most people think of it as an object is connected to a reference frame in some physical way. But a reference frame is not a physical thing. It's just a mathematical abstraction.
Yeah, but that wasn't the issue. The issue is whether or not when we talk about something being in the same reference frame, yes, that might be worth getting your contribution. When I say something is in the same reference frame, is in a reference frame, and something else is not in that reference frame, do you believe that statement is possible for something not to be in a reference frame, and B, if you believe something's you can have things that in and out of reference frames, what would you say defines something being in a reference frame? How about that?
Yeah, well, coming right back to it, a reference frame is a mathematical construct, not a physical situation. And so anything can be in any reference frame at any moment. And it cannot be in any reference frame at any moment. A reference frame is just when we say this object in this reference frame. That's all.
Right, I haven't really answered. Okay, I'll give my volunteer.
Or this vector, right? This vector in this reference frame.
So I would say two objects. I think I regard two objects as in the same reference frame if their coordinates don't change with regard to the reference frame over time. So in other words, something that's for instance, if you're an aeroplane going along at 500 miles an hour, whatever, and I would say the reference frame of the aeroplane. If you have two people who are both sitting down in the seats, not moving, they're in the reference frame of the aeroplane because their coordinates are not changing with regard to the reference frame, which I'm calling the nose of the aeroplane. So I would say those two people were in the same reference frame as the aeroplane. Whereas if someone was to get up and walk around, I would say their coordinates are moving with regard to the origin of that reference frame. Therefore, I would say they were no longer in that reference. Although you can say what they are doing with regard to that reference frame, I would argue that they are not in that reference frame anymore.
It sounds like you're kind of stuck in the physicality, which I'm stressing. Reference frames are not physical.
Yeah, I know, but I'm matching a reference frame to make it easy
to a physical object.
Yeah, well, I know we all know that reference frames are just mathematical. Yes, I know that, but I'm attaching this reference frame to a physical thing. Well, perhaps I didn't.
Right.
But it's still, still a coordinate system. Sorry.
Well, then when you say an object is in a reference frame, you're implying that it's something about the nature of the object has caused that to be so.
Well, no, it's the movement. I'm saying that it's in that reference frame because its coordinates with regard to the origin of that reference frame are not changing over time.
Right.
So those two people, the coordinates of those two people that I was describing sitting down in an aeroplane, if I decide that my reference frame is the nose of the aircraft, I would say that those two people are in the reference frame of the aeroplane. That I'm going to get this mathematical thing, yes, but I've attached it to this, just to give it some sort of easy to understand thing. Whereas the people who are walking around are not in that reference frame.
Right. I understand what you're saying, but what you're saying is very dangerously close to correct. It's so close to correct that it's dangerously wrong, which is that they are in the reference frame you say they're in, and nothing more. So the people on the ground are in the exact self-same reference frame as the people in the plane if I want to work the math problem that way. Their connection or their motion has nothing to do with what reference frame they are. But we so often we just connect people to the reference frame of the thing they're moving with that we sometimes don't even bother saying it.
Well, I could argue there's another aeroplane, okay, if you want to make a mathematical point, there's some mathematical reference frame that's moving along, I don't know, 100 miles in front of the aircraft, and that the coordinates, and there's some people on the ground perhaps who are traveling 500 miles an hour in a super rocket car or something, and they're all moving together so that their coordinates do not change with regard to some origin that I've decided, and this origin is moving around, and so they're not moving around at all, and therefore I'm going to say that they're in the same reference frame as that origin defined. I've defined this reference frame, and I've defined its origin, and I've defined obviously how it moves with regard to other reference frames, and I'm saying these other objects or these points, if you don't want them to do mathematically, are in the same reference frame because they're not changing their coordinates in this reference frame that I'm picking over time. Whereas if I had other objects, obviously you can still refer to other objects from this reference frame. I see that NerdLert is telling me to stop.
We do speak that way. We do speak that way. Colloquially, you were correct. We will say like, "Oh, I'm in the reference frame of the airplane," and we mean I'm moving with the airplane. I'm co-moving with the airplane. But technically, what a reference frame is just the axis. So when I say I am moving at 0 meters per second in the reference frame of the airplane, and the people on the ground are moving backwards at 1,000 meters per second in that same reference frame.
Yeah. So
right.
Okay. So yeah, I did say you can still reference all the other objects in the universe from this reference frame.
Yes,
but it's the concept of whether or not, because quite often, I mean, I've seen physics lecturers describe this is in this reference for these objects are in this reference frame, and then some is in this other reference frame. So there's this concept of being in or out of. Although you can still refer to other objects, I don't think you're not. I'm not quite. Perhaps
so there is a common assumption, I think, that people make that if you don't specify a reference frame, that you're talking about the one you're co-moving in. Maybe. I don't know. I think there's a lot of people talk like what you're saying, that the passengers of the plane are in the same reference frame as the plane. People talk about things that way. But technically that's not right.
Well,
but
they can if you want them to be. They can be in the same reference frame if you choose to allow them to be there.
Yeah, exactly.
But,
They're in whatever reference frame we're discussing.
right. I can put every passenger on any plane in a different reference frame. There's no problem.
Yeah,
with
but obviously
that.
everything, as I said, you can still reference everything from a reference frame. Nothing. You can argue that in that case, then nothing. But the phrases used, including in physics lectures, this is in this reference frame. Now, if we're saying that everything can be referenced is in every reference frame, then it makes the phrase "this is in this reference frame," unless you want to just say from the perspective of this origin and this coordinate system.
That is what they're saying, Compass, when they say that.
Yeah, I think the
When
point
they
that
say these are in this reference frame means all of these equations that I'm writing, all of these velocities and positions are referred to that reference frame.
Right.
Yeah, but I'm not denying that's not possible. You seem to be disagreeing with something I'm not saying. Oh well, I think I'm not saying you can't reference things from other reference frames. You seem to be implying that because I'm not saying that.
Yeah, you're saying that in the there's a common usage where people refer
including by
to
physics lecturers. Physics lecturers will say, in the reference frame of these things are in this reference frame, and these other things are in this other reference frame. Now, we all know that you can still reference other objects from other reference frames, but it's just a phrase. I mean, perhaps it's, physics lecturers do this as well. I've seen numerous physics lectures and been in them where they've used this phrase, and so it's not.
The common mistake these flat Earth guys, a lot of them, and a lot of our guys, honestly, do the same thing. They fail to recognize what you guys were talking about earlier in the fact that a reference frame is not a physical thing. It is not. It's not like rooms in the house. You don't. They treat it like you physically leave a reference frame and physically go into some other reference frame. And it's not like you leave the bedroom and go into the master bathroom. It's not. No, it doesn't work like that. It's not a physical thing.
Yeah, we know. Yeah, I'm not really saying. Yeah, I mean, okay. Clive is saying he's never heard the phrase being in this reference frame or that reference frame. So I mean, I've seen lectures on this, but Clive is saying he's never heard that phrase. Okay, well, I mean, because that's what I'm trying to defend. The use of the phrase. Anybody who says that in this reference, this is in this object, is in this reference, that, and if you've never heard that term, and Clive's saying he's never heard it, then that's really where, because I'm saying that phrase would have no meaning.
Just pick a point in space and put a coordinate system in it at that point.
Yeah, I think people do sometimes say that, and I think what they mean is that if you have an object, or particularly a human, an observer, that we would very often say in the reference frame of this observer, right?
Yeah, I mean
we would understand that what we're doing is we are creating an axis system attached to that person's eyeballs, right?
Yeah, I mean that's not what
exactly.
Yeah.
Yes, I'm not disputing that.
No, you're. I'm in agreement with you on that. I think it's pretty common to do that.
Okay, I mean, Clive's saying he's never heard that phrase, so.
I think I've heard that, but it does lead to the confusion. This is why I call it dangerous. It leads to the confusion that if I were to jump out of the plane, that I would be leaving that reference frame.
No, that doesn't imply that, because as I describe what I believe that something's in the same reference frame. Well, yes, sorry. If you jumped out of it, yes. As I say, if you just moved around, you could say you are no longer in the reference frame defined, because you're moving around. Your coordinates are no longer fixed with regard to the origin of that particular reference frame. I mean, obviously, you could just change it by saying you are moving with regard to this position or with regard to the origin of this particular reference frame. But it's just the phrase. It means that you can't use the phrase in this reference frame, basically, or you can say, or no, you can say it. You can say because that's where it defines the origin and the origin and the coordinates and the scale factors and things. But you can't say something like you would have to then say if all the people are in, say, if you were describing an aeroplane, you would have to then say that all the coordinates of the people are then moving along with they're in the origin. You'd have to define them as being the velocity, having the same coordinate as the origin I've picked for the aeroplane. Now, whereas you could just say, as an economy measure, it's in the same reference frame as the aeroplane.
Yeah.
But I mean, it's a fiddly little thing. It's not really a.
Well, the reason it's, I think, such a round and about is that, like what was his name? That engineer Brian somebody
Mullin
botched it. Yeah, I think that was it. Who botched it? Right? He was talking about the airplane moving eastbound, and then it turns 90 degrees.
Yeah.
And at some point during his math, he dropped the transform.
Yeah.
And
it was just terrible.
And lost track of it. He just lost track of it on the board. But that's the kind of thing that happens when you don't really seem to have a full grasp of what this means, or you're being a little fast and loose. Maybe you understand it completely, but you're speaking a little too imprecisely about what the reference frame is. You can do the thing where you turn the plane and suddenly you've lost 1,000 miles an hour of its speed.
Yeah, he didn't understand what he was doing. Yeah. And he demonstrated that on many other occasions about thermodynamics and God knows what else. And whenever it got to things moving around, he just got it completely wrong. He was a complete idiot. Anyway, I just thought but perhaps I ought to have a discussion with Clive Wells about reference frames, and that would whether or not. But if he has, all I'm saying is the phrase in this reference frame. Basically, Clive's saying he's never heard it. I think you were saying, So I was just trying to say it means that phrase will be useless, completely pointless. And I'm sure I've seen physics lecturers use this.
I don't know if
anyway, never mind.
I don't know if it was in lecture, but I've definitely seen pop size stuff where they talk about the train reference frame, and then there's the track's reference frame, and we have the observer on the track watching the train go by, right? We do that all the time. And I think they often say, like, and this guy is in this other reference frame. I think I've heard that.
Yeah,
it's a confusing thing to say. To say that there's a physical object in a in a reference frame that's attached to a physical object is kind of it's a good way to confuse people.
Well, I say I've seen physics lecturers describe it as such, but anyway, never mind. It's a very tiny thing. It's an opinion thing, really. I'm not. It's not.
Yeah, really, it is, and that's where I'm coming from. I'm just coming from like how you teach this subject. If you teach,
yeah, I mean, obviously with the maths. I mean, once you get to the maths, obviously, and you just describe coordinates and things moving relative to one another, then it all becomes very clear. It's just an English thing.
Yeah, I mean, well, it's the I guess in flat Earth, it's the foundation of why can't you just raise a helicopter and then let the Earth rotate underneath you? Right. That's the fundamental misunderstanding, is that the helicopter has left the reference frame of the rotating Earth, and therefore the Earth should rotate without it.
Yeah, they do. They do use that as a lever to get into it, but obviously that's if it wasn't that lever, they'd use another one. Obviously, I don't.
Well, yeah,
it's not. They're just going to find some way of trying to. They're confused by the conservation of momentum. They're confused by So that's.
Well, they're confused by one of the things. I think a lot of people are misunderstanding what is a reference frame. When the helicopter loses the connection to the Earth, it does not mean it's in a different reference frame. The reference frame is a purely mathematical concept. It changes whenever I damn well feel like making it change. That's it.
Exactly. You can do that as well. Absolutely. Yeah. Anyway, I just thought that'd be an amusing, just a slight blue and I just discussed this.
I know this. I never flew an airplane that knew anything about reference frames. Not on one.
Right, but you've never flown an airplane that knew about maths either, have you?
No.
I mean,
all my airplanes knew all about the difference between airspeed and ground speed.
Yeah, they know that.
Well, the airspeed is the reference frame of the air, and the ground speed is the reference frame of the ground.
Yeah.
There you go.
Blue, if you have some, oh god, I've forgotten his stupid name now. The guy who got all those things on about aeroplanes and angle of attack. Brian, as the other Brian, yes, Brian Brian Logic. Brian's Logic. If he's still been doing stupid videos, I couldn't on airplanes and things.
He still does stupid videos. He hadn't done one on airplanes in a while.
Right. Okay. I mean, I've not been subscribed, so I don't keep an eye on his. I mean, he's just so stupid. It's just. I can't bear to watch his videos, and when he got those things like angle of attack and stuff, oh my god, and whatever.
I actually made some progress with him privately.
Really?
Yeah.
Oh my god.
Yeah, I was meaning to do a video, but that was right at the beginning of the school year, and I'm busy. But
I did used to have him years ago. I used to have him on Skype, and when he claimed that Big G was a speed, and I hammered him for about an hour on Skype trying to explain that Big G was not a speed, and he just couldn't get to grips with this. I just gave up and thought there's no point in talking to someone this stupid, this delusional, and they didn't really understand the difference between small g, big G. Didn't really understand what was it, something basic as well about force and acceleration as well, and also about geometry. I mean, just so much. There comes a point, and also, I mean, like Sleeping Warrior, when what was it, 3 or 4 years ago, tried to explain what force was, and he's gradually worked out what a force was. But God, he didn't believe that, for instance, when you were standing on some boards in a floor, that the boards were pushing, to keep you stationary, that the boards were pushing you up as much as you were pushing down, and when I asked him, well, hold on, what's when the boards break and you fall down, what happens then? I can't remember what his answer to that was. That exhibit therefore showed that the force existed, but there comes a point where even I, who has been told that I'm more ruthless and prepared to go for longer and longer with these flatties, eventually even I was worn out by him. So yes, Brian's Logic did it to me in the end. So right, but so Blue, you're monitoring his behaviour, his videos at all, are you?
Well, sort of.
Right, okay. I just find him too annoying. Okay.
He is hard. It's hard to do a debunk video on anything he does, because most of his videos run 30 minutes, 45 minutes, but he only says about 5 minutes worth of stuff in there. It's just that he says the same 5 minutes worth 30 times.
Yeah.
It's incredible.
Yes, and you made some very good videos. I mean, the angle of attack one, where you put quite a lot of effort into showing what the difference between that and your attitude. He didn't understand any of that, did he?
Well, I think if I remember right, that was actually what I managed to get through to him about.
Really?
Yeah. Was it? Yeah, when you're flying wings level, and straight and level, angle of attack and attitude, same thing. But when you're not flying level, that's not the same thing.
Yeah.
And
indeed.
Yeah, he seemed to get that even.
Really? Oh, God, okay.
Yeah, and there is an important lesson maybe for us in that when you attack somebody,
oh God,
they become defensive.
No, you're going to tell me that no one ever learns anything by being attacked by it. Sometimes you can't put up. I mean, I spent hours and hours with that guy going things like with the G and big G. I can assure you, I have used the lengthy, very careful, very gentle explanation technique, and I can, having done this for longer than you have, I can tell you that most of the time that just get the more nice, and this is where other people try and use the sort of nicely approach, and unfortunately, and then claim to be enjoying getting abused for it. It doesn't get you anywhere. 99% of the time. Sometimes you can, if you're a reasonable person, but there are a lot of people out there who like the Bevs of this world, who you cannot just be nicely, gently encouraging them to get from A to B. You have to give them a big shove, and you have to show them they're wrong. Very wrong.
Have you ever moved Bev at all?
Some things, I mean, feel like
Bev is movable.
Well, that's why I've refused. Someone like Nathan Oakley, for instance, there's no example. He's another Bev character. I don't know if you're familiar with Nathan Oakley. He's a real abuser. He's even worse than Bev. And I have got him to change various bits of his language, where I've beaten into him that he's wrong, and he's actually had to know, because I do use diagrams a lot, and with Bev, of course, he censored me on his channel because he doesn't like the fact that I use diagrams. And in fact, I've been on there to show him about drop and things, and he refuses to look at the diagrams, because he knows that I've got a very compelling argument, and I think so. What he does, he actually blinds himself to the points that are being made to him. Where someone like Nathan Oakley, who has a very similar attitude and even more abusive, I've actually got them to change their language, and Sleeping Warrior as well. I've got a number of flat earthers to change their position and the language they use through just the force of argument, and particularly with using diagrams. Sorry?
No, that was my Bev impression. Good.
All right. Yes. And so I have actually had an effect on a number of them to change their arguments, give up on many arguments, in fact, particularly with Nathan Oakley. But I haven't. But with Bev, because he censors diagrams and things, it's been and I've been less successful with him, perhaps, even though I have made him change his language and his positions on things, actually, but not so much recently because I've refused to go into his chat because because he censors diagrams. So yes, I have got these people to change. So yes, it does work sometimes. The gentle, I mean, the slimy arguments, I'm afraid, never work. You can be gentle, as I say, but even with some of them, you can be as gentle as you like and incremental as you like. And I'm afraid it's not necessarily going to work. The angle of attack one is an easier one to get through. I mean, that's something he can accept without. I mean, if you were tackling him, for instance, about one of his issues, he calls optical drop, which means something moves away from you, it actually descends. Because that conflicts with something he's fundamental. I think he's prepared to accept angle of attack as an easier one to get through to him. I mean, Blue made a video about it, but it's something he's prepared to accept because that's a new piece of it that doesn't conflict with his view of the world. Whereas if you were to tackle him on a subject where it was crucial to the way he viewed the world, I mean, something like he believes that the Earth is the sextant works, and the and was it these? He believed the angle. He thought the minutes of angle. Oh God! He drew a square box basically for a sextant measurement, and therefore you give you the height of the star that you were looking at. And if you try to tackle him on that, then he would just go into something equivalent to his refusal to understand that G is not a speed. So I think you got him on an issue that he was more susceptible to being corrected. So don't get overexcited about your achievement there, because it won't. Because I think you'll find you'll be less successful on the more substantial issues.
I think it's. I think we should probably start with a person who's unwilling to accept will not be moved by anything.
Yeah.
That we have to first presume in teaching. You have to first presume that the student is in the remotest way interested in
yes.
in changing their position.
Why is that? Why wouldn't you just want them to understand? Why are you trying to get them to just understand? Why are you trying to get them to convince them of something?
Because we're trying to teach them something useful about the reality.
Accepting it doesn't mean you can't understand. That was just a weird thing for him to say from a teacher standpoint. You want your student to accept it rather than understand it. That was a little strange.
Perhaps that is a bit strange that I use that word, because in the context of these, the denier is different from understanding. Although I have talked to some, and you make a good point, some that will agree to understand what I'm trying to say, and yet not believe it, but to say, oh, but I see how you would believe that. I think that's movement. It's an improvement. Is that kind of your point?
Yeah, that makes more sense. Yeah.
Yeah, most of them though don't even accept the reality of what you're saying, and I guess that's really what I was meaning when I say accept it. I don't necessarily. I don't care if they. You can believe what you want, but look, this is reality. I think we should agree to that.
So you would start with common ground. That's interesting. Yeah. I mean, not the whole. You wouldn't take the whole entirety of some sort of whatever this belief is based on other, examples, and then you add it all together and say that's reality based on me adding all this plus this plus this equals reality, because that person hasn't experienced all of those things. So, but some sort of common ground. That's interesting.
Yeah. Well, I would say that if the person whom I'm calling the student refuses any acceptance of, I use the word acceptance, refuses to understand, refuses to accept or believe or listen, I don't really think there's anything you can do about that.
Well, where would you find yourself in that situation ever?
Talking to Bev.
This is just with Bev.
About
I mean, with any others, like example, I don't know, like what could you give another example where somebody would just be like, I can't accept that. I hear what you're saying, but that's just not true.
Well, yeah, that's there's a friend of mine who's a flat earther that I've spent quite a lot of time trying to take him through the concept of air pressure and space, right? The phrase is, how can you have air pressure next to space? And it's a tough conversation because it's very deeply ingrained with beliefs.
Yeah, I mean, separate. Well, I understand I meant separate from the flat Earth, right? If you're trying, I thought like you and Rumpus were trying to get like a relatable, like to somebody. How do you get through to somebody on anything?
Well,
like
I think
having high pressure next to low pressure without a container is pretty tough, right? So, like if somebody said, hey, if you were to say, hey, listen, I got all this math and all these formulas for how jet skis can actually just fly through the air, right? That could be like an example. Like, somebody could be like, yeah, I understand all the math that you're putting there. You got it. I see your column. It adds up to something, but I just never seen it. So I don't think it's going to happen. Right. Like is that what you're talking about? Like,
yeah. I think that's the normal. I think it's either the normal human condition or it's a very common human condition. I think that really that's why I get into this in the first place, is because the flat Earth is such an extreme example of that. But I think we all do it to a lesser extent.
Yeah, I mean, I guess to bring it back to like, I don't know, maybe Bev or flat Earth or something, like what could you show then? Like what is it that, like, what's your number one thing that you show when somebody's like, I'm not buying it? You're just like, well, like we can go and do this and you can see this in reality. Because that's what somebody had based it on, saying, accept your reality. Like,
yeah, I guess I typically just start with the sun sets. Where is it going? And, if you can get an honest person to just point at the sun and say, okay, where is it at noon? They point up. Where is it at 8 p.m.? And they point to the horizon. You say, okay, keep going. Where is it an hour later? An honest person has to point below the horizon. Right?
They do? I don't know.
Well, it came up in the east. It went up. It went up straight up. It goes down. It goes down to horizontal. It has to get back to the east.
Right, but have you ever seen? I mean, have you ever seen that happen? Like where you ask somebody who wasn't in the argument, where does the sun go, and they point down?
I have found that someone who starts from a flat Earth perspective will not do it. They won't point.
Point down? I mean, nobody points down.
They won't even join the conversation. They already know where it's going, and because they know where it's going, I think they won't do it.
So well, not that you have to answer what I was asking, right? But when I said, what's a real life situation in reality you could show somebody, something, and then, but in reality, nobody points to the ground when they point to the sun. So that was kind of that didn't work.
Well, look, if
no
you
flat
ask
earther does, but everyone else does.
You ask me where the sun is at midnight, that's where I'm going to point, straight down.
I was going to say,
yeah, you can ask a 5-year-old, and that's what they do.
They won't. 5-year-olds won't do that. That's what I'm
yeah,
saying.
They will.
I mean,
yeah, they absolutely will. Yeah.
Let Alan talk here.
So I was just going to say, if you literally ask me right now to point to where the sun is, I'm pointing at the ground because I'm in the UK, and it's it's fairly close to almost straight down. I mean, not that it gets dark not that it gets to nighttime this time of the year, because we only have astronomical twilight this far north. But
Yeah. I mean, but that's your idea. I mean, that's like your idea of where it goes, maybe, I guess, right? But like, if you were to ask somebody, As soon as you see that sun point to it, they're never going to point down, right? Like, so that's not really something you could show somebody. They're never going
I
to point
think
down. Like, no matter where I go, like me, like no matter where I go when the sun is out, at least, or when it's daylight, whatever you want to call it, no matter where I go, no matter how high I go, no matter how low I go, the sun is always shining down on me, at least even at the smallest of angles. It's never shining up. Like, I'm never like walking around and I'm like, the sun, and like I'm holding my hands towards the ground to block it. Like, it's shining up into my eyes. It's always, no matter how high I go, how low I go, it's always up. It's shining down.
But you recognize that it is that it's the ground blocking the sun, right? That it's down there, under there somewhere, right?
Oh, I don't know.
if I went out with my 3-year-old grandson and we watched the sunset together, and I asked him where the sun was, he would say under the ground.
Maybe. Yeah, I don't know. It was just about showing. Like, what could you show? You can't show that part, you know? That's probably not a great one, but it's still a fun one to go over, and it's interesting, but it's just not like a show it thing, because you're not. It's gone. That's the point. You can't show it. It's gone.
Interesting. I don't know. I'm a little dumbfounded, honestly, that somebody would not be able to put that together on their own. That they would have to see it under there to believe it, I suppose. I mean, I could show you pictures of a neutrino scan showing you that it's still down there. Does that mean anything to you?
Yeah. I mean, it's something.
Yeah. Okay. Well, I guess there's that. If you find, I also find different people find different things compelling. Very, very few people are interested in the lights in the sky.
But
it's just. I mean, there's nothing wrong with it. It's good. It's just it gets more complicated. If somebody doesn't accept that it goes down, then it gets more complicated, right? Like I was just saying, what was something like? Well, maybe that is your number one. That's all right. I was just wondering what your number one thing
is. If you ask somebody and they point to the flat Earth model with the AE model with the sun going around, and you say, okay, point to this map where you are. And on this map where you are, where is the sun at sunset time? What angle is that? Let's go and watch. And then we will see where the sun actually is, and it won't match the AE model.
Yeah. Especially if you're in the southern hemisphere.
It gets worse and worse the farther south you go. But yeah, it's not good for anybody, really. Yeah, and
what could you show? What could you show Bev? Like what? Not like show him. Not like I don't. What's the right word? What could you not show him? Right, like a sunset gone. Like that. You're not showing him something. Like what do you think you could show him? You would to a student who did. Yeah.
You couldn't show Bev anything because Bev is a DLC.
What?
I don't think I know DLC. Downloadable
disingenuous, lying, swear word beginning with C.
Cracker. Yeah, I know. He's white.
Yeah, I agree, and that was my point as well. Is that when someone wants to resist, they can resist, and they will. There's been studies on this from ages past where they show that literally people's ability to do math, just arithmetic, it degrades if it becomes ideological for them.
Well, that's what I was going to ask you also, like a follow-up, but I didn't want to go there right away. But since you brought it back up, what do you think it is then stopping someone like him, not him, but somebody from, what do you think it is stopping them from accepting or even looking further into it or even giving their heart for a little bit to think that maybe this is possible? What do you think it is stopping them?
Well, I think that we've learned in recent decades that the human mind is more complicated than we at first thought. That we know that there are multiple processes going on at the same time. And so it's very complicated. and everyone's different. But I think that the largest driving factor is social group identity. It's tribalism. I think that the flat earthers are an extreme example where their mind is very specifically segregating itself from the established society group. And they have found another social group with which they identify. And they put up a very tribal sort of wall there. It's the butter side down versus the butter side up, right, from Dr. Seuss, if you guys remember that one. It's wrong to butter your bread on the bottom, because that is what my tribe says.
So you think that it's so why would somebody leave the so it's not about finding is it more about finding a new tribe, or is it more about leaving the other tribe then?
Mostly it's about, I've seen, and this is
Is it like a rejection of the mainstream more
Yeah.
so, or is it acceptance somewhere more so?
I found that they're both related, but it seems like the rejection is the stronger force, at least initially, usually.
Interesting. So then, then it would make you wonder, like, what is it in the mainstream that somebody, your student, whoever they are, is rejecting that is, like, I guess, detrimental to their life? Like, let's say that they had I don't know, like they had a parent who was like disabled, right? Like, and just mentally deteriorating, and the mainstream told him there's no hope, and it's actually your fault for putting your mother through all this stress. Right? Would that be like a reason to start rejecting the mainstream, like something personal like that? And now everything they say must be wrong because the consequence is that they're right and I'm bad and I did something wrong.
Everyone's very different. We all have very complex backstories and lives. And the best I can do for you is to look for a common thread throughout all the people that we've interacted with, on these various servers and in these various discussions. And you don't find a lot of strong math backgrounds amongst the flat Earth people, for example. You find a lot of abject complaint about math from that side, and just like really bitter complaint sometimes about when we show math equations. And to me, that definitely indicates a certain likelihood that that these are people who had a very bad experience somewhere in their formative years about math. Somebody told them they were bad at math. Somebody failed them at math, or they just didn't like math. They didn't like their math teacher. Who knows, right? Anything could have happened. It could have been, like you said, a specific story that sent them.
I feel like it would have to be something more than just being bad at math to reject a whole group of people, right? Like only like 3% of the world is good at math, right? Like, so
Right.
that's not, it can't be. Maybe it can. Maybe nobody knows. Maybe everybody's like, shit, I'm the only one who sucks at math. I think,
I definitely think it takes a little more than that for somebody to go full on. But remember, this is a spectrum, and we all do it. For all the various things that like, think about everything you think of as an establishment concept, and which ones of those do you personally reject or disagree with or have trouble with?
Every single one of them, yeah, probably.
Right, and we all live somewhere on a spectrum of that, I think. Maybe there's somebody out here who's just like, whatever the establishment says, that's me, I'm down. And maybe somebody else says, I believe in all of it, but not politics, right? Or not economics, or not medicine, or how about every mechanic is a liar, right? mechanics are a classic. It's stereotypical to imagine that the mechanics are trying to rip you off.
Yeah, I mean, it's not true. It's not that mechanics are liars, right? I'm not a mechanic. Like, I'm not like projecting here, right? But it's not that they're liars. What it is that they're a bunch of like grunts and idiots, right? And idiots don't accept when they do something wrong, right? It's never their fault. And then they say, well, your thingamabobber was also broken, but they know they broke it, but they can't accept that. They can't take responsibility. So now they're like, well, you got to fix that too. So now they're just liars, because it's really because they're a bunch of assholes who are immature, who will never accept responsibility for making a mistake or misdiagnosing something. So now they're just thrown in there as liars, but they're all just idiots, really, not liars.
Okay, yeah. I mean, I think that's a really classic example. And what you describe is I think, cliche. I think there's mechanics who are talented and honest and good. And when you find one, give me his number.
Yeah.
They're hard to find. But also, it's a complex problem that they're dealing with that most of us don't have enough experience with to really question their answers. Right? Most of us aren't mechanics. And so when he says that rattling noise is because you need a new serpentine belt, you're like, oh, okay, I guess we need a new, right? Either you're lying to me or I need a new serpentine belt. And so we're kind of stuck, right? And I think that's the same for all of these fields. Do you trust your dentist? Do you trust your medical provider? Do you trust a geologist? Do you right?
But do you trust them more than you? Like, that's the thing. Like that's what it comes like. Yeah, trust them, sure, right? Until then the rattling noise starts making a sound again, the exact same sound as soon as you drive away, and they say, no, it's fixed, right? Or the dentist says, no, there's no cavity there. But every time you bite something, you're like, that's fucking killing me, right? So it's like, it gets to a point where it's like, all right, well then show me, and then with the car, I didn't, if you don't believe them, and then a month later it's rattling worse, and then it breaks. It's like, okay, yeah, it definitely wasn't what he said it was. Yeah, I mean, they've shown themselves to be human.
Yeah, well said. Well said. And I think the reality of it is that we're all human. We're all human, and if we walk away from this, bad interaction with the car mechanic, with a sort of a tribal line that we've drawn. Okay, car mechanics are scumbags. I know that now. Then that's not a accurate portrayal of the world either, right? But we do tend to to be.
Right, but like almost in every situation, like mechanic, dentist, whatever, right? You give them another chance, and you say, well, I'm going to treat this person as an individual, right? Like racism, for like example, right? I can't imagine, hating, just deep down, like deciding to hate an entire group of people just because they all behave exactly the same way. That's a joke, right? Yeah. But but we do. We give these.
I was just like, holy crap! I hope he's joking.
But no, it's the comedian's joke. I just copied it. Right? But we give these other people another chance, right? Like, so, these mechanics are rip-balls, right? But then you eventually will take your car to another mechanic. Oh, this dentist they all suck. But you'll eventually go to another. You'll go and give these other people a chance until they show you wrong. Like, or women or men or whatever the situation is. Like, oh, I hate whatever, right? But you'll give them another chance, right? You won't just single them all. You'll lump them all generally, but you give another one another chance, treat them as an individual. What's the difference with this globe and everything else? They won't give it another chance.
Well, I think if it becomes personal, if it becomes like part of my personal identity, then that's when the real separation takes place. Like they say about like in politics, I can debate policy with anybody, but I can't debate their identity with them. Right? So if you have someone who has a different political view than you, as soon as they've made that part of their personal identity, that is no longer something that you can debate them about, right? And I think we all experience this. It's right.
So then when you label yourself, so like I think Bev's against that, right? But when you label yourself something like a Republican or a Glober or a flat earther, you then take on that identity and you can't let it go.
Right. Labeling is a classic part of it, but not exclusive. You don't have to label yourself, but it's a good way to indicate that.
Well, the way you described it was as soon as
when you identify yourself that way, it's part of your personalness.
Yeah, when you identify yourself as a flat earther, then that's your identity, and you can't let it go. Or if you identify yourself as a globe earther, and it becomes part of you, and it's harder to let it go. Yeah. But I think he's against that, doesn't he?
No, he's not against that.
Well,
he hates being labeled, but he's got himself a little following, and they have their refrain, they have their chants, right?
Chant?
They're chanting their, I don't know, prayers, essentially. Phrases that they repeat.
Like what?
Level is horizontal. Like, what else? What else does he like to say? Loves to say, is a water level a tool for establishing horizontal?
Well, it is. Yeah. Well,
I don't know, whatever he says.
Yeah. Like a water tool is a tool. Yeah, that's the water level is a tool. Yeah, that's what he says.
Yeah. You know, the various things. They're very repetitious.
That's just. I mean, that it's just like saying whatever. Like just saying
an identity for them, right? It's an identity.
Maybe. Yeah, I was just curious about chants. I didn't know they had chanting.
Yeah, I don't think they would describe it that way, but that's how I see it when I read what they're saying or listen to what they're saying. They repeat the same phrases.
Well, because like you started, I think that is maybe the only thing, right, that you guys can agree on.
Is what?
That a water level is a tool for establishing a horizontal plane
It's
of reference.
No, I don't think I agreed with that.
Oh, you don't?
No. A water level is a tool, sure. Okay, I'll give you that. And it can establish level. Yes.
How does this? Right.
But no,
I mean, it doesn't.
To be pedantic, for a moment, a water level consists of 2 points, and 2 points does not define a plane. So, if you want to say that's creating a horizontal plane, you need to retake your Euclidean geometry. It does not.
I mean, just in that, I guess, that dimension.
Sure. So,
but it is a tool.
Create a level. It creates 2 points that are at the same level.
Yeah, same gravitational potential.
And if you connect those 2 points with a straight line, then you could call that a horizontal line if you wish, understanding that it's only horizontal at the center point of that line. But normally we don't care about that.
Only a straight line is only horizontal at the center point.
By the way,
so it's straight.
Yeah.
So it's straight between. So it's straight at the middle.
No, it's straight everywhere.
It's perpendicular to vertical at one point, and that's at the middle.
Yeah.
It's at the middle,
Yeah.
right? But then what if? Never heard that. So then what if you just move, right? Like I got one end, you got the other end, and I just take one step forward.
You've actually established a new vertical.
No, but like
A new
that
horizontal.
center is still that center. I went there and I marked it or whatever, right? And I said there's a center, right? And I put a level on it, a plumb bob, whatever. I marked this is my horizontal line, and then way back in the distance, you just take one step forward. How does that line change in the middle?
Yeah. Well, here's the thing, right? If you start with the presupposition that gravity is parallel, then an equally level surface will be flat. But if you set that aside and consider for just a moment that perhaps gravity is pulling everything towards a central point, then a level surface should be spherical. And if you can just say to me, yeah, I get that those are two possibilities, then we can start a meaningful conversation about it.
Yeah, I mean, I'm not worried about all of that. I'm just worried about like outside with the water level, right? Like to do it, to project a horizontal reference. You just get two ends and draw a straight line. I mean, I'm not worried about the consequences of the Earth being a shape or not a shape or whatever. I mean, I'm just saying this is how you get a straight line, like a horizontal straight line.
Oh, okay. So how do you define horizontal?
Like 0 degrees, like no slope. Just
Relative
straight.
to what?
Relative to vertical.
Okay. So how do you define vertical?
90 degrees to horizontal.
So they're just defined relative to each other.
Yeah, they can define they can define each other. Yeah, if you're going to hold it relative to something, yeah, and it would be relative to that.
I have a book. Right? I have a book, and I'm holding it so that the corner is at the top, and there's another corner at the bottom. Are the sides of the book horizontal and vertical?
I don't know. A book. I got a checkbook in my hand now. You said one's curled at the top.
One corner is at the top, so it's diagonal, right?
I don't know. I'm going to read it. Like I'm going to open up and read it. I don't know what you're saying. Hold it flat on the table. Like lay it flat on the table. Now what?
So before we go any further, for anyone who's still listening and interested in this, this is an example of something that is very, very easy to understand. But it's going to be very, very hard if either of us is ideologically invested in the result.
I literally just have a book.
We are. I think that one of us is invested in this result. It's tied up with our identity.
Right.
So we're going to see that just a very simple concept of I'm holding a checkbook diagonal.
No, I got an actual book now. This is a Dan Brown book now. I got a bigger one so I can see it. All right, go ahead.
Okay, so I'm holding a book, any kind of book, checkbook, cell phone, anything square, rectangular, holding it diagonal.
Holding it diagonal.
Uh-huh.
To what? All right, diagonal.
So, one corner. Somebody else help me out here. If I'm describing this in a difficult way.
Well, I do have my rectangular book on my rectangular table. You want me to turn it diagonal like a diamond?
Hold
All right.
it up
So I turn
in front of your face. Hold it up in front of your face. So you're looking at the front of it.
Just hold it up by one corner.
Hold it. Yeah. Hold it in two fingers by a corner. How about that? Yeah.
Oh, okay. There you go. All right. Now what?
Angle down. Now the top and the bottom of that book are parallel with each other. And the sides are parallel with each other.
Mm-hmm.
And the sides are perpendicular to the top and bottom.
Right.
The sides are vertical and the tops are horizontal.
To what?
Not
Each
not
other. That was your definition.
not.
Well, they're perpendicular to each other, but it's sloping.
They
tilted.
won't be the edges won't be vertical if you're holding it between thumb and forefinger by a corner, because gravity won't allow for that.
Well, the definition that No Tanks gave me for horizontal and vertical were that they're perpendicular to each other. Didn't mention gravity.
Oh, I just said having no slope. Yeah.
Having no slope relative to each other, you said.
Well, I mean, you got to establish one of them. You got to establish one of them first. You think this diagonal book is either vertical or horizontal? I don't know. What tool would you use to
I think
establish
that you've,
a vertical or horizontal?
yeah, I think that you left out something that was crucial in your definition, and that's why I'm trying to explain that horizontal is perpendicular to vertical. Good. I'll check. Write it down. What is vertical then? Vertical must be defined in some way other than merely perpendicular to horizontal, right?
No. You're just asking how do you establish a vertical or a horizontal. I mean, that's not other than you can't just tilt the book sideways and say that it's flat. That's what you did. I didn't realize where you're going. That's cool. I mean, that's a cool idea and everything, but it's neither. It's neither vertical or horizontal. It's just a book in the air.
Can you define for me what does vertical mean then?
90 degrees to horizontal. Yeah.
Okay, so what is horizontal?
90 degrees to vertical.
Does that seem circular to you?
Yeah, because you're asking the wrong question. Yeah.
Okay, what would the correct question be?
How do you establish horizontal or how do you establish vertical?
Okay, how do you establish? I was saying the word define, but okay, how do you establish vertical?
Well, you can establish vertical with a plumb bob.
Okay, excellent. So, do all plumb bobs point parallel to one another, or do they perhaps point towards some central point?
You have to, I guess, check it and test it.
Right. Well, are you willing to suggest that those are two possibilities?
That what? Well, then it wouldn't. What was the question?
Are you willing to accept that those are
before that
possibilities, that either they're all parallel or perhaps they all point to a central point?
Oh, plumb bobs.
Yeah,
right?
plumb bobs.
Okay. Not vertical, just plumb bobs.
You said that a vertical was determined by a plumb bob. So if the plumb bobs all point to a central point, then the verticals also all point to a central point.
No, I said a plumb bob is a tool that you can use to establish vertical. I mean, if I were to just say whatever the plumb bob does is vertical, right? That wouldn't be fair. Then I throw it on the ground, or if I put it next to a magnet or whatever, right? That's not a good idea. You just have to, you can use the plumb bob to establish a vertical, but then you want to check it based on it being perpendicular to horizontal.
So, right.
Can I interject a quick question to think about, given that last example?
Yeah, take it away. Take it away, man.
I have yet to find a actual plumb bob that is made from a ferromagnetic material. So what would a magnet have to do with it?
I don't know. I mean, you didn't make your plumb bob out of something magnetic? I don't know.
Lead. Most plumb bobs are made out of lead, and lead does not react to magnetic fields the way, say, a piece of stainless steel will.
Can I make a plumb bob out of stainless steel?
You could, but you would be introducing error into what you're doing.
Yeah,
Your traditional plumb bobs, to get true vertical, you want to use something that minimizes the number of confounding factors that you're going to have, magnetic fields being one of them. So you use a heavy, dense material that is not reactive to magnetism.
Sure. Good idea.
I have seen a fair few plumb bobs made out of brass as well, of course.
Yeah, brass is typical.
So anyway, I think I'm gonna wrap it up here, guys. But I think thank you for that excellent example of exactly what I was describing, which is that it's really very trivial to put this together. It's not at all complicated to say vertical is what the plumb bob says it is. Done. Period. Stick that on the blackboard. Until it becomes part, something that conflicts with your personal identity, and then all of a sudden, no, that's not acceptable anymore. And that's exactly where we're at, right? So, yeah.
Oh, me and you?
Yeah. I mean, that's exactly what vertical is. Vertical is what the plumb bob says it is. Done.
What the plumb bob says it is. I don't know.
Uh-huh.
I mean,
that's it. That's all there is.
That's it. I mean, that's who
vertical.
discovered the first plumb bob and just said is what it is.
Right, and so you're going to continue to fight me on that, even though
no, it's just weird. It's just I thought you guys could agree on something, but like I mean, nobody just grabbed the plumb bob, right, and was like, I'm going to call this thing Bob, and this nickname will be vertical, and whatever it says it is, it is. It doesn't just tell you what is.
But plumb bob's pointing the direct plumb bob. The string of a plumb bob is orientated vertically by definition of vertical.
Your vertical you can't define vertical with the word vertical, and then say, well, plumb bob is vertical. It's not. That's circular. It does sound circular.
And where you've gone is to refuse to give a definition of vertical. That's where you've backed yourself into. You've backed yourself into the situation where you will not define what vertical is.
I thought we agreed to it together.
That's what a plumb bob
That's what I said. You went off on this thing and said this is where we disagree. I thought we were in agreement the whole time.
No, I'm going along with you, right? I'm going along with you until you resulted in a contradiction, which didn't take very long.
I must have missed it. What was it?
Okay. To review, your first definition of vertical was perpendicular to horizontal.
No, that was my third. It was having no slope, being horizontal.
Okay, having no slope. Yeah, you know what? I think we've illustrated the resistance to basic.
Just trying to be clear.
Enough.
Just trying to be honest and clear with it.
So, I will give you an example now of basic, very clear logic.
But you notice that three times you keep jumping to the whole perpendicular to horizontal. But I had to keep reminding you I said no slope.
The definition of vertical, the definition of the word down, is derived from the way the plumb bob hangs, or specifically, let's just call it plumb bob. That's good enough. Without using the G word. And so the way a plumb bob hangs is how we define what down is. That's what vertical means. Horizontal is anything perpendicular to that. And that's it.
You say so.
Yeah, I do.
I don't think you're 100%.
Anybody want to contradict me?
I learned it on a piece of paper on a desk. You know what I mean? And it was, explained how, what vertical and horizontal are on a piece of paper on a desk that was tilted, probably 10 degrees from the horizontal. That's how desks look.
I mean, if you want to get down to as base and simple of a language that can be used to describe the terms, I see no issue with the way ICST described it.
Described what?
Where's the contention?
What? I don't know what described what. Vertical?
Horizontal and vertical, and the relationship between the two.
How did he define them?
Were you not listening?
Well, if you had no problem and thought it was really crystal clear, could you just reiterate it? It's not an argument. What was the definitions?
that vertical is the direction that a plumb bob hangs.
And
Always.
horizontal is 90 degrees to that.
To it.
Okay. Right. Okay.
So what's
And
the issue?
A plumb bob is what?
A heavy weight on the end of a piece of string that you hold up in the air so it is free hanging.
Okay. So a plumb bob can just be anything on a string.
Exactly.
Okay.
Well, a heavy weight that will hold the string tight.
Okay. And no matter what, the string is going to be, no matter the shape of the heavy thing or anything else like that, it's going to hold the string perfectly straight and vertical.
Correct.
All right. So we don't need a plumb bob. We can use anything. We can use a rock.
Yeah.
Well,
We can use anything.
a rock that is tied with string such that the rock does not fall out of said string would serve as a rudimentary plumb bob.
Yeah, just anything. All right. And
Yeah,
it'll always
as long as we can
vertical.
attach it to the string, it will always hang vertically if it is hanging freely.
Okay. And what do you do with it?
That is a visual representation of vertical at the spot that the device is positioned.
So what do you do with it?
That string is now plumb.
What you do with that depends on the application and what you're trying to do. Are you trying to build a fence? Are you trying to map out a local area? What are you trying to do? Because that's what's going to determine what you use with the information that you just gathered by establishing your local vertical.
Right. So I'm just asking you, like, what would you do with it? To, I guess, I can science that. He said he goes on to Bev's Discord and they can't agree on anything. Like, what do you do with this rock and string now? He said that they have these chants. They say like level is horizontal, and something else. I can't remember the other one.
So now the beautiful thing since you want to go to Bev, the beautiful thing that Bev loves running away from people like me about is that you can set up 2 plumb bobs a known distance apart and then actually establish that local horizontal for each one and compare them to each other. And what you find out when you do that accurately, repeatedly, with even just basic precision, we're not looking at 4, 5, 6 significant figures of accuracy. You can do it with 2. And you will see, let me finish and you'll find out what you can do. You compare those 2 local horizontals to each other, and you will see that they are not coplanar like Bev likes to state, but they
How are you doing that? You're just making a statement. You're not saying like what I do next is I do something. You're just
Why are you afraid of listening to a full explanation before interjecting?
Oh, so maybe you'll get to it. Go ahead.
When you take 2 plumb bobs a known distance apart and you compare the local horizontal established at each, Bev's assertion is that they are coplanar, that they are parallel, that they are the same.
How do you compare the 2 at 2 local points at the same time? I mean, that's what I'm asking you. How are you doing it? You made the statement like it's something you do. Like I mean, it's not some kind of I don't know, aggressive question. You're like, when you take these 2 horizontal.
Why do you keep interrupting?
Yeah, I don't know if you can hear yourself. You're not like getting to it. How do you do it?
I have hang on. I have been patient. I have been giving you a chance. I listened a while from the audience before I joined in.
Go ahead.
I had a smell that there was something off with you with the way that you've been interacting and talking. And this right here actually feeds into my suspicion that you actually don't care about the subject. You don't. Because you're not interested in having a conversation. You're not interested in having people actually fully explain what they're saying. You start to see where it's going and you don't like it and you have to interrupt. Just like Beverly.
No big deal.
Anyway, Jared, how have you been? I haven't spoken to you for a while.
I've actually been keeping myself busy with other endeavors that are rather more fruitful and entertaining, but have been taking up a lion's share of my time. Yeah. New employment where people actually value you appropriately tends to do that.
It does, doesn't it? Glad the new job is working out for you.
Yeah, and it's one of those jobs that all I can say is that I work for a company that manufactures and supports heavy lift equipment. Yeah. I am legally not allowed to say any more than that.
Fair enough.
So what do you think? You think, well, let me close this. Hold on. I'm echoing because I was watching this stream. You think that you know, Blue and Einstein and Bev can all agree on something? Like,
no, because Bev is a lying, disingenuous lying C word.
DLC, man. Yeah, I know. DLC.
Exactly.
Nothing. They can't even agree on just like the beginning of like vertical, right? Like vertical, like a plumb bob establishing vertical. They can't agree on that.
Correct. I mean, I've told him this to his face. In fact, I called him a DLC to his face on a live stream. I also used his full and correct name when I did it, which he really doesn't like as well.
Yeah.
But you know,
he's not like an open book, that Bev. I don't know what's what he's really about. I don't know. He's very guarded. I can't really ever get like, I feel like I'll be asking him an honest question, right? Like, like, what are you into, or just whatever, right? And I just can't ever get an honest answer. Like, or I don't feel like he's being honest, right, about stuff. Not that he's lying, just I don't feel like he's being forthcoming with much. He likes to keep everything close to his vast family, everything else, what he likes, all that stuff.
Well, I mean, some people don't like talking about their families in public, and I can understand that, and I wouldn't ever fault him for that. But
I got no problem with that.
But the absolute outright lies, that's a completely different matter. Especially when he denies, especially when you've got two of his statements viewable on screen that contradict each other, and he denies that he's lied about either one of them.
Well, let's not forget that Red's rhetoric got Beverly to actually admit that when he's talking about the shape of the Earth, he's just taking the piss out of everyone.
This is not Beverly. Stop it.
Oh, no. I was in that stream where Red's got Beverly to admit that. Everything that Bev posts and says that is pro-flat Earth or can be taken as pro-flat Earth Bev admitted that he was just taking the piss.
That's the only time he's lied about something?
No, that was him admitting that he lies about things, certain topics, repeatedly. Some would even say obsessively. And also with his behavior and about him not wanting to talk about his personal life. But he's had no problem trying to talk about other people's personal life when it has suited him. It's kind of a double standard. But you know what they say about a lot of conspirators and the mentally deficient. If it wasn't for a double standard, they'd have no standard at all.
Well, it comes down to this, and it's just disingenuous. No one can make the claim that level is horizontal and then deny that they think the Earth is flat. It's
The
just
Earth
not
is
possible.
flat. Yeah. The Earth is flat. Yeah, I had a friend once say something like that. Said what was it? It was something about he says, if the Earth were a globe, then it would be, if it would be longitude, latitude, and curvature would be required, like curvature, right? But it's just longitude and latitude. But I can't deal with that because that means that we're all just flat, just like these 2D creatures.
Yeah, but at the same time, think about this. Latitude and longitude are used to describe the surface of a shape. Doesn't matter the shape, just the surface of a shape. When you're talking about the surface area of a three-dimensional object, is it given in 3 dimensions or 2?
Just the surface?
Just the surface.
I mean, how thick is the surface?
The surface is the surface. We're not talking about depth.
So there's
When
no
you're talking
depth.
about,
Then, yeah. If there's
when
no
you're
depth,
talking
then
about,
there would be 2 dimensions here. There's 0 depth.
exactly.
Right.
Exactly. And that's what latitude, longitude for positioning for navigation is. It's just surface. When you want to go to an elevation, that's where you do a lat long and then a 3rd digit for elevation above either mean sea level or the center of the object. That's where your 3rd dimension would come in.
So like if I was at, I don't know, like whatever, if I was at, I don't know, like 40 degrees.
74 north, 41 west at X elevation. There's your 3-dimension, including elevation.
Well, that's what I was going to ask. Say, so if you're at 70, 40, right?
Yep.
You're right at that spot, right? And then you elevate, I don't know, 100,000 feet into the air, right? Like where are you? You say you're still there, you say?
Yes, you are still at 70-40, but now instead of being at 0 elevation, you're at that given altitude above that point.
Yeah, there's no depth, no matter, even if you're just, so you're still at that coordinate, no matter how high you go. That sounds like it's just like my friend described. No matter how high you go, you're still at that. Like there's no depth to this. That's coordinate system.
But think about it this way. Think about the coordinate system as a street location. You have a building number, a street, and a zip code that hones you down to the physical building. Does the building address change no matter what floor you're on?
Right, yeah.
Wait, the building number changes based on the floor you're on? Yes or no?
Oh no, I was saying right. I'm agreeing with you.
Right. Exactly. So why would changing elevation change the point that you're above?
Well, does changing elevation now give you a new point, a new horizontal point?
But where did
it's the classic radio tower. The latitude and longitude of the bottom, the latitude and longitude of the top. Same. Now the elevation is different, and the elevation is different, and an airplane can be flying along and have that radio tower on its navigation, and he wants to fly right over the top of it. His navigation will say, "Oh, you're there," and you look straight down, and you're at the radio tower in the latitude longitude system, but not in the elevation system.
So not in the elevation system.
Well, yeah, because the elevation of the top of the radio tower is, say, 2,000 feet, and you're at 10,000 feet. Okay, so you are at the same latitude, longitude, the same address.
But you would be like, I'm just thinking, like, I'm just
But
thinking.
you're on a different floor.
But you're on, you're above it. But your navigation says you're at that XY position.
Why does it say that? Like, I'm gonna draw. If I drew on a piece of paper, right? This is what I'm saying. If I drew on a piece of paper a circle, right, and in the center, I just drew diverging lines in the center, right? Now at the very high, that's 120,000 feet or whatever from the surface of the circle. I draw a little airplane. That's going to be above a different latitude, longitude.
No.
It's going to be tilted way away.
No, it's above exactly the same latitude and longitude.
Only
latitude and longitude are independent of whatever size the sphere is. Doesn't make any difference.
No. I just drew it on a piece of paper. The airplane is above a different point on the circle now.
It's not above a different point on the sphere. It is not. It is exactly the same point.
Yeah, it doesn't even matter what three-dimensional shape you use. If you are using polar coordinates for a three-dimensional shape, you have two angles and a distance from the origin. And the distance from the origin,
equal distance from the circle. What do you mean?
If you have a sphere, then the latitude and longitude will have two angles, and the height is the distance from the origin, which is the center of the coordinate system, which is also going to be the center of our sphere. Then it doesn't matter how far you are along that, how far you are out from that origin point, which is your height. You're always going to be on the same latitude and longitude, because you haven't changed the angles. You've just got further away from the middle. And technically, it doesn't matter what shape that solid object is. It can be a sphere, it can be a cube, it can be a polygon with 55 billion sides on it. Although with 55 billion sides on it, it's pretty much going to be approaching a sphere anyway. But either way, it doesn't matter. The angle, the two angles from the origins and the distance are always, the two angles are always constant, and the distance is what changes as you change elevation.
So, like when you fly over a mountain, are you at a different latitude, longitude? Because it's
no.
No, okay. Just the center. Gotcha.
The ground's at a different distance from the origin.
Yeah. Flying over a mountain is just like flying over a radio tower. The radio tower is a radial line. It's because it's vertical. And when your latitude, longitude of the airplane is the same as the latitude and longitude of the tower, then, yeah, in that latitude, longitude system, because that only involves the angles, yeah, you are on that radial vector from the center of the Earth through the radio tower and into the airplane, just one radial line.
So how do you not get confused then? Like when a plane like goes higher and lower, then all of a sudden you're at a different latitude, longitude, just because you
You're
changed
not.
height.
But you're not
You
okay.
never
Okay.
are.
You have two planes flying in formation, one above the other, and they both indicate the same latitude, longitude, and they both indicate different elevations, and they're flying along.
How could
And
that be?
Never
They're
mind.
different. They're different distances from the center.
Yeah.
That's right.
That doesn't, because the distance from the center is not used in the defining of the latitude and longitude.
Oh, okay. It's just the surface.
In fact, it's just angles from
Just
origin
angles.
points.
Right. So it's just an angle. So if I descend in altitude, I'm at a different angle. Therefore, I'm at a
No,
different.
you're at the same.
Oh.
You're at the same angle. You're just at a different distance from the origin.
I'm at the same. How I'm at a which? What am I at? Same angle.
In the office building that has a singular location, you're in the elevator, and you look at your GPS receiver, whatever the hell you want, and you get a latitude, longitude, and you get a height, and then you ride that elevator on up. The height is continually changing, and the latitude and longitude is not.
Right. Yeah, I know. That's what my friend was saying. That we're just like these flat, just flat. It's just flat. Like two dimensions.
That doesn't do anything for showing. It doesn't prove flat.
There's no vertical change. It's just flat, like just two dimensions. That's it.
What do you mean no vertical change? There was a continual changing elevation.
And then somehow we still stay flat.
Along a radial line that goes from the center of the Earth on up through the top of the building.
And how do you know? How do you know that when you're up at the top? How do you confirm that the latitude there?
The same way you confirmed it at the bottom.
How?
Measurement, a variety of measurements, and the fact that the elevator shaft is vertical.
Well, I'm just saying. You're saying these things. You said the way you confirmed it on the ground. I don't know. Somebody said, okay, you're on the ground, go straight up in the air. You're at this. If you were to drop, you're at the same. You're at the same latitude and longitude, right? It's like flat. It's like there's no depth to it, no matter what. No matter how high I go, no matter how far I go, you're saying I'm at the same point, like I went nowhere, right? Well, but I know I went up.
To define whether or not it's flat or not, you have to compare two verticals. And when you compare the two verticals,
you said that already.
Yeah. So yeah, if just because you're in one elevator shaft going up and down, much like all the different positions along a radio tower, latitude and longitude is constant. It doesn't tell you anything about shape of the Earth unless you compare two radio towers a significant distance apart. And then you notice, yeah, they're slightly not parallel, and they're pointing to a common point. Those two verticals pointing to a common center of the Earth, and you do it all the way on around the Earth, and you end up with shape.
What? How you see two radio towers are pointing in a different direction? Means something? I don't know.
No, Tanks. Do you actually understand what polar coordinates are?
Like I said, I got this piece of paper, right? And when I drew it flat, when I drew like a flat line,
do you understand what polar coordinates are? Yes or no?
Oh, okay. You're talking about distance from the North Pole only?
No, I am asking you, do you
understand
what polar coordinates are in geometry?
No, go ahead. What are they?
Because
he doesn't know geometry.
Yeah, obviously.
So, absent knowing geometry, yes, this is a circular, argument on our part because we're talking to a wall.
You are? I mean, I'm just drawing on a piece of paper here. I don't. What's the problem? You're telling me that the way, right? So I drew a flat line, like my friend said, right? So I drew a flat line, and I can draw these little dots, and so call these like coordinate system, right? So I drew 3 dots in the bottom line. I can draw a line straight up, right, at the same distance, right? Like saying whatever, and they'll all be, they'll all, go straight back down. But now when I do that on a sphere, like a circle, I mean, I drew a circle now, and I did the same thing. there's a different distance now. There's a different distance that would put, as you raise it in elevation, you would be at a different latitude position or longitude position.
This is why you do this. This is why it is obvious you do not understand what polar coordinates are.
Yeah, I mean, I'm drawing a piece of paper. I mean, you're just saying words. Yeah, you're saying
because what you are describing are not polar coordinates. What you are
you're talking about.
are,
Yeah, no, I am. I'm talking about the length of that straight line being the same.
No, you're bloody not. You're talking about you're talking Cartesian. You're talking a circle and describing it using Cartesian coordinates. They are bloody different.
Whatever. It's a piece of paper, man. I mean, that's it. So you're telling me no matter how high I go from the surface of that circle, right, with this, pen and paper I'm using, right, that I'm at the same position, but I'm not. I'm looking at the piece of paper.
If you are going to draw this on a sheet of paper, so we are doing it in 2 dimensions, not 3. So yes, we're going to use it with a circle. You draw your 2 axes, okay, and you draw your circle. Now, Cartesian coordinates use the angle from one of, if you draw if you draw 2 axes, because that's what we're used to with Cartesian coordinates, you would count distance along the x-axis to the left and right horizontally normally, and distance up the vertical, what we would call the vertical axis, or the y-axis. But with polar coordinates, you would start with, say, what is your x-axis, which is pointing off to the right, and you measure the angle around the circle from that point. So vertical then becomes a polar coordinate of 90 degrees. That's that's how far round you've gone. Then to define how far from at any point, to define how far you are from the center, i.e. the height, you measure the length from the origin to the point on the circle. Now, because it's a circle, that distance will always be the same. Yeah. So if you have, so in 2 dimensions, you would have one angle and a distance from the center. So 30 degrees and, I don't know, 6,371 kilometers. Yeah. You can move a bit further around and you have 60 degrees and you're still 6,371 kilometers from the center.
Center of the circle?
The coordinate system, which is also the center of your circle, because your circle is based on the center of the coordinate system.
All right, so I draw a circle on the ground, and then no matter where I go, I'll be equidistant from that circle, the center of it.
You take one point as your 0 degree point, and that can be anywhere on the circle. That can be in any direction from the origin. And to define a point on that circle, you measure the angle around the circle from your origin, from your 0 direction, and you measure your distance out from the origin point.
Good. Yeah,
and that's polar coordinates, and that is something that you really need to be able to understand, because we actually use polar coordinates for lots of things in science and engineering. Because sometimes it's just easier than trying to do it in Cartesian. And And if you're going to get to three-dimensional objects, then of course you have to have two angles, because you have to be able to go around two separate angularly around two separate circles. That are orthogonal to each other, i.e. at 90 degrees. So instead of having a line, you have two planes that are defined, that are orthogonal and are defined as 0 degrees on each. One. And then you just define how far you are from the origin to give yourself your height. Now, of course, when we're talking about things like that if you have a sphere that's centered on your coordinate system.
Oh, that's good. Yeah, that's interesting. Well, no, I mean, that's what I was saying.
So if you have your polar coordinates with a sphere centered inside a sphere, say that sphere has a radius of 6,371 kilometers. You might then, and that's the surface. You might then define out, distances above that, and instead of defining them as 6,000 excuse me, instead of defining them as 6,471 kilometers, you might define that as being 100 kilometers above the original surface that you had. But either way, because we know that the radius of the surface is 6,371, we can subtract that from every altitude so that we know the distance from the surface we're worried about.
The surface of what? I mean, where's the surface?
The surface. Well, if you've got a sphere.
Where is the surface? I mean, are you talking about 39, 59 miles? I mean, I'm not a kilometers guy.
I prefer to use SI units when we're talking about this stuff, which is why I suggested you might have a sphere of 6,371 kilometers.
Right. So if you had that 6,370, like where is the surface? 6,371 at?
It's 6,371 kilometers from the origin.
Yeah, but where is the 6,371 like spot that I can stand? Where can I go to it?
Well, if we actually have a perfect sphere that is centered on your origin, then anywhere on that sphere is 6,371 kilometers from the origin, isn't it?
So everywhere I stand is 6,371?
Yeah. From
yeah,
the
that's
origin.
flat, man. There's no depth.
No.
Again.
No.
Everywhere I go, I'm 6,371. There's zero depth. Like my friend said with the latitude longitude. Flat little pancake people.
You're 6,371 from a point, no matter where you go. Now, what would that define?
Nothing. I don't know.
It defines a sphere.
So on the surface, right, of Earth, I guess we're talking about, right? Where is it 6,371?
I'm talking about any random set of polar coordinates, and I just happen to pick the distance from the origin for the surface of our sphere.
Yeah, but all right.
Which is 6,371 kilometers.
Right, it was 39, 59 miles, I guess, right? Because I'm not into the SI.
I have no idea, because I don't memorize that, because this is science and engineering we're talking about, mathematics and SI units all the way back.
What I'm asking you is, are you referencing the radius of the Earth with this?
No, I'm not.
Okay.
I'm not. I just happened to pick 6,371 kilometers because it seemed like a nice round number.
Oh, how the hell is that round?
It's round in my head.
Yeah.
It's round in my head by definition.
Oh, jeez. Yeah, so like on the Earth, then where is it? Where is it?
It's
You
fair
know,
because it's the distance from the origin of a polar coordinate system.
right? Okay, yeah, that's in your polar coordinate system. Okay, so yeah, I thought maybe you were talking about the Earth being a globe and somewhere having like a distance that was equal from the center of it, and I was asking where is that spot?
Well, I mean, if you've got, like I said, if you have a perfect sphere that is centered on our polar coordinate system, then any point on that sphere is going to be 6371 kilometers from that origin point, if that's the size of the sphere I've defined. Now, if I define a sphere of 1,000 meters radius, that means that any point on that surface is going to be 1,000 meters from the origin. It doesn't matter. It doesn't matter what size it is. That for a sphere centered on a polar coordinate system, the surface of the sphere everywhere is going to be the same distance.
Yeah, so like on Earth, like where can I stand at 6371 from the center?
Well, on the Earth, of course, 6371 is the mean radius.
Mean radius.
Well, because the Earth is slightly oblate, so it's not. And also, of course, Earth has got terrain as well, so it's not a perfect sphere.
So there's nowhere on Earth that it's that.
Oh, I'm sure there's loads of places on Earth that are going to be 6371 kilometers from the center. It's just that without going and checking, I can't tell you to go to this exact spot and you'll be that distance from the center of a polar coordinate system, simply because
but we definitely won't
it's not
be.
a question I can answer without.
Yeah. But we know that we definitely won't be 6371 everywhere we go. I mean, we're not flat. It's not flat.
It's not. The Earth is an oblate.
Realize how big the Earth is.
Yeah.
If the Earth were a pool ball, it would be legal for tournament play.
The Earth were a pool ball.
If the Earth were the size of a pool ball, it would be far, far smoother and far, far rounder than a legal pool ball by about 10 orders of magnitude, I think it is, in fact.
Yeah, that's what I said. My friend has an issue with that, like, cause, then he's just everything's flat. It's just perfectly smooth and flat.
Scale. Yes. The thing about in the Earth's orbit is also pretty much a perfect circle. If you were to draw, it's like the error is if I were to draw you like 4 circles and draw you one that was the Earth's orbit, you couldn't tell the difference except by chance. It's that round. As a typical flat earther, you have no idea of magnitude, scale.
What?
You have no idea about scale.
Me?
Yes, you.
Flat. That's what I have a problem with. It's not flat.
It's scale. It's relative. Again, if the Earth was the size of a pool ball, it would be legal for tournament play.
Like flat, like perfectly smooth and flat.
Pretty much, yeah.
No,
if it
smooth, perfectly smooth and spherical.
But you're saying there would be no no undulations, right? Like just perfectly flat.
No, there'd be undulations, but they'd be so small, just like a pool ball, you can't see them because you can't perceive something that small.
Can we measure them?
Yeah, if you get like a microscope.
So how do we measure this? How do we measure this on the Earth?
Oh, I don't know. Should we put a satellite in orbit with a radar system in it and measure the distance from the satellite to the ground? That'd be a good way of doing it. As
But
the
you just told
satellite.
me it would stay the same. You told me it would be the same distance all around.
No, we would be. You asked for a way to measure it on the actual Earth. I just gave you an option. Now, if we're going to do it on a pool
Right.
ball, probably
No,
a
no,
scanner.
no. On the Earth. No, on the Earth with the satellite. You told me that no matter how high I went, like in the elevator, in the building, it would still be at the same latitude, longitude. No.
Yeah, but we
Right.
can, but we can put the
Black.
satellite. We can put the satellite in a circular orbit around the Earth,
Right.
and we can measure the distance of the surface of the Earth from the satellite using radar.
That's just a straight vertical change, right? That's not that you tell me that proves the surface being something now.
Yeah, well, okay.
Are you really this dense, or are you just pretending to be dense?
No, he told me that.
I am starting to
you are
think
pretending to
Poe
be dense
here.
because you really do understand what he's saying. You're just pretending to be dense.
This guy's got to be a.
You're telling me that you put a satellite up in the sky 100,000 feet, whatever, 200, 300,000 feet, and no matter where it orbits, it's still
you can't be that low in orbit. You have to be at least
400, 500, 600, whatever number, like 1,000, 75 miles high, whatever, right?
Try more like 400 kilometers.
So all right, so you put it 150 miles high, and no matter where it goes, it's going to be equidistant to the ground.
450.
No, it's not
450 kilometers is 280 miles.
Right.
It's equidistant from the center of the Earth. They put it in a very precise orbit.
I don't know. This wasn't this was him saying. He said a way to do it with satellites.
I know what he's talking about. You're either too dumb or you're pretending to be too dumb to understand this. They don't put it. It doesn't orbit relative to the Earth's surface. It orbits relative to the Earth's center.
And that's how you prove the surface?
Yes.
Oh, weird.
Or you can go out there and do it the old-fashioned way, like Britain did, like America did, and you can start surveying it with the transit.
Yeah, that's that.
Which one are you going to choose, other guy who doesn't keep saying you must be dumb?
You can do both of them.
No, other guy.
You can do both of them. We've done both. The satellite is much more precise, and you can cover huge areas much more precisely.
Me as a former military radar technician, I'll pick the satellite with the radar. However, however, I know enough people around here within this group that are actual surveyors that are perfectly capable of doing it the old-fashioned way, and I'm sure that we would both get very similar results from doing it.
That's crazy. Don't you think that's crazy? It's like no depth again. Like you're saying that you're going to get the same results 400 miles apart.
No, you're going to get the same results using two different methods.
400 miles apart. Yeah.
No.
Crazy.
You're a Poe, and I'm done with you, Poe.
Yeah, you're a Poe. You got to be a Poe. You got to be a Poe. Why don't you just bugger off?
I don't know, man. I don't know why you're having an issue with it right now. You just told me, right? Like that you would use satellites, right? And have them orbit in a circular path. Is that right?
Yes.
And when, yeah. So
they would orbit the center of gravity of the Earth in a circular path.
I mean, that's just, I don't know the consequence of it yet, right? I'm just saying we put it up straight up in the air, 400 miles is where you want it, right? And it's going to say, hey, I'm 400 miles above the surface of the Earth.
Well, I've got a feeling this is going to go on for a while, so I think I'll just say goodbye to everybody out there in YouTube land. Thanks, I appreciate everybody showing up, and I guess I'll see you on the next one. You guys take care.